Testing 1 2 3. Testing 1 2 3. Sorry about the wait, guys. Testing 1 2 3. I'm finally ready to come online for a new day of streaming, if I'm not mistaken. Yo, what's up? Ooh, welcome back to Vencabot. Intro to Python action. My name is David. You're kind of hanging out here. I just had a delicious frozen dinner. Oh my god, it was fucking good. It was called a vegetable burrito. Man, it was godlike. Hang with my guys in the chat before we get the stream started here. Signap says, screwed around in class with buddies and teacher didn't get mad until the girls left. That's weird. Am I saying that he or she's given the girl's preference? Maybe I should get an HDMI capture card, says Kenny. It's very useful. It's very, very useful. Depending on what you want to stream, I mean, if you're streaming retro games, definitely use an emulator. Faust, I guarantee that even though I've spent like 4 to 5 hours working on my overlay today, something will fuck up, and I'll get very angry. Sarky says, if Aaron Schwartz was here, things would be different with Google, Facebook, etc. Who the hell's Aaron Schwartz? Wait till you come to Florida one day, says, here goes. I will make you a real veggie burrito. Dude, I need food, and I'm very grateful to finally have it, whatever the food is. So, I'm gonna actually go over here to my music here. This is kind of, let me look at something real quick. I apologize about the interruption here, but there's this beepity boopity going on here that's kind of frustrating me. Where is it? Right here. Now this is supposed to be deteriorating, but it's not at all, right? No, it is kind of a little bit. Sure it is. Okay. This seems weird to me, this whole beep. I'm actually going to neutralize the beepity boopity. Neutralize the beepity boopity. There we go. That'll do. Sorry, guys. Okay. So, what I got here in the chat. I used to work at a tropical food place, so burritos are a specialty of mine. Dude, I had never cooked anything in my life except for a burrito. And I fucking love them. I'm sure I'm nowhere near as good as you, though. He was one of the people behind Reddit. Killed himself, the FBI say, huh? Wow, that's weird. Aaron Schwartz. Sounds like a conspiracy. Come to Kansas, all you see was grass and pizza. Well, nothing wrong with that. Some guys like grass and pizza, especially together. Alright, so, last time we streamed, we streamed Intro to Python, right? We've been doing kind of a mix of, game dev stuff lately. It can be kind of confusing for new viewers. Basically, Monday, Wednesday, and Thursday, we stream, game design, game development for our channel's game. Right? We're kind of making a game together as a channel as like a fun project. But on Fridays, guys, it's Intro to Python. This is a whole different game. This is a game designed to teach Python to absolute beginners. And we've been working on it now for 3 weeks. This is our fourth week, our fourth Friday working on it. And what we've accomplished here is pretty nice. We've actually made a very simple sort of a Dragon Warrior-esque JRPG, right? Where you have one-on-one combat with a monster, you're playing as some kind of hero with a sword, and you can, as of right now, you can actually defeat a series of monsters, and with each monster you defeat, you can gain gold, right? And you start off with a few items, including a potion to heal yourself with, and that's kind of our game right now. It's kind of like a game where you fight endless monsters and try to accrue as much gold as you can before you die by making tactical decisions about how you spend your items, essentially. And today I want to expand that dramatically by allowing you to take that gold you've earned and use that to go buy more items and upgrade your character. That's our goal for the end of the stream today. And that's going to make our game much more interesting, more decisions to make on how you spend your gold and that kind of thing. And also more areas to explore, right? As of right now, all you do is you fight a monster one-on-one in a text-based battle. And we'll soon have shops to explore, and even new dungeons to fight different kinds of monsters. And we're going to be implementing that all by finally bringing in object-oriented programming concepts into our program. So in the past, guys, this is Intro to Python Season 3. We've actually completed 2 other projects already. And typically, about this time in the series, around halfway through, we'll introduce object-oriented programming, which is where you take things like classes and objects and instantiation, and you use these ideas to make your code more readable and more extendable. But right now our code is pretty rigid, although it is not that long, and it does work pretty well. So before we get started here, I'm actually going to read the chat one more time, and then kind of go through our program real quick and see how it's working so far. You could put some salsa verde, huh? That sounds pretty delicious. Faust says, yeah, they found him with 3 gunshots to the back of his head, huh? Wow. Pretty ballsy way to kill yourself. Well, that's disturbing. Must have had a combo shot, huh? Yeah, more programming. And update the GitHub, exactly, Starkey. The GitHub is already updated. It's been updated, I believe. But, also I published a new video on YouTube, finally, for Intro to Python. Okay, so let's go through our program and see what all is good here. So basically, these are where we're defining our functions for our program, and most of these functions, unlike in real-life programming, these typically have a direct correlation on the gameplay, right? Whereas in a real-life, larger program, our functions would oftentimes be doing behind-the-scenes type stuff, right? That's a very, very common in any kind of program. Lots of behind-the-scenes stuff to do. But our game is very simple yet, so most of these functions actually correlate directly to the gameplay. As you can see here, we have the attack turn you can take if you're the protagonist, and the defend turn for the protagonist, and the item turn. You can use an item on your turn as well. And then after that, we've got all the items you can use, including the spears functionality, the roll of toilet papers functionality, the potions functionality here in a function, and the thumb drive functionality. The thumb drive functionality is very, very limited right now, right? You really can't do anything with it yet. Then we have a function here. It's kind of like a setup function for behind the scenes. One of our few functions that actually does something behind the scenes. It's called create new protagonist. What it does is it takes the game state as an argument, right? So you supply it with a game state, and then within that game state, it creates a new protagonist. That's kind of what it does. Because a game state is itself a mutable object. We talked about that last time, right? Mutability, which means that if you give it to a function, then that function can change that object. So the game state here is mutable. We give it to the function, then the function changes the game state. It mutates the game state by adding a protagonist to it. Right? That's kind of what this does here. Same with the create new monster, right? It creates a new monster in the game state, sets them up for you, and then you can fight that monster. Now we have the player's turn right here. This is the player's turn data. So when the player gets his turn, we run this function to sort of ask the player what they want to do and then do it. Then we have the monster's turn, where if he attacks, he does this. He has a taunt that the monster can do right here on his turn. He has a defend he can do to lower the defense, lower the damage takes on the next turn. And then here's the monster's actual turn happening right here, the take monster turn. And finally, we have this do battle function, which is a an overall larger function that shows battle beginning all the way to its end, right? So in this function here, we have this entire battle that starts, including the monster starts approaching you, and then we display the the monster's at HP at the start of the match, and then suddenly we have this fight, right? And there you go. And then down here we have the end of the fight, right? This function is kind of long. It might suit us to split this function into more than one function. You see what I mean? Like this function do battle here is a little bit long. As you guys know, the code block is indented by 4 spaces. So this entire function is sort of indented by 4 spaces. That's longer than one full screen. This is all within the do battle function, right down to here. Right, so it is one full screen's worth of code. And down here we actually have our main program logic. So we've defined all these functions, right? We know what they do now, but they haven't done anything yet. So functions, when you define them, you call them later. They don't do anything right away. So here's what's actually happening. We define a game state right off the bat, now that our functions are defined. Then we create new protagonists in the game state. Then we say, while the protagonist has health, then keep on doing battle over and over again. Right? Then when the battle's done, print game over, and you're done. Right? So the actual game, the main thread of logic, the main progression of logic for the game is just these few lines. Right? But these lines themselves are calling functions that are calling other functions. That's kind of making this whole thing above us happen. Right? All these functions are getting called in turn when they're needed. Okay, the Foss was joking. Signap says, this reminds me of setting up a night full of D&D and Minecraft with Pepsi and some Halo Reach, huh? Sounds like an awesome night. What's up, Vucat? Welcome back, dude. It's still same game. Yeah, we're running this game as well for 2 more weeks. We do 6 episodes per season of Intro to Python. So today we're kind of like halfway through on episode 4. Hey, good stuff, Stignap. Finished the base of his house, huh? A new house, because you were living in the old tower before in Minecraft. Okay, so let's, before we get fully started here, let's go kind of follow this logic through, right? So first we make an empty game state, and the first thing we do with that game state is we create a new protagonist in that game state. Let's go look at that code real quick. That's up here somewhere, right? Create a new protagonist, right? So we give them a name by asking the player what their name is, right? If they choose Chun-Li as their name, then they get extra attack power, right? Otherwise, they only get 6 attack power, right? If they're Chun-Li, they get 10. Otherwise, they get 6. And they have a certain amount of health that gets added to the game state. And then they have a defending state. If the player's defending or not is added to the game state. They have an inventory is added to the game state, right? Including a few items for them. A spear, a roll of TP, a potion, and a thumb drive. And they have 0 gold, right? So when we kind of create a new character, we set up all these variables in the game state. So the game knows what this protagonist is all about, what his stats are, etc. Right. After that, all we do is we do battle. Right? As long as the player is alive, we keep on doing battle over and over again. So what's going on with this do battle function? Well, we know it's our longest function, right? It's right here. This entire thing is a function. First thing it does is it makes a new monster. Right? Let's go check what that logic is like. What are we doing here when we make a new monster? Well, we randomize the monster's name. Right here with this random.choice method. So before we talked about libraries, right? Python libraries. And a library is sort of a toolbox that you can selectively bring into your code. So if Python came fully bundled at all times with every single feature a programmer could possibly want, it would be a very, very large program every time. It'd be storing a lot of data that it doesn't need. So what Python and other languages allow you to do is they allow you to work with a very basic set of tools that's enough to do many, many things, as we've seen in the past. But then also, if you want to do more complex things, you can selectively import new tools. So what we've done here is we've actually imported random. As you can see, if we go to the very top of our program here, we start off by importing a library, random, right? And we can call tools in that library by using its name, random, and then a period, which means ownership in Python, right? That means kind of like an apostrophe S. We're saying use random's choice function, right? Use random's choice. And choice is a function or a method that will take a list of things and then give you a random item from that list. So here we have two different names we can choose from, Goki and Baby Goki. And we're gonna get one of these at random when we make a new monster every single time as the monster's name. Let me say here, listen, well, if the monster's name is Baby Goki, well then give him these attributes, right? This amount of HP and attack and a gold value. However, if it's not Baby Goki and it's actually Goki, then give him, more HP, more attack power, and more gold value, right? If you defeat them. Then we say, we give him a defending state, which is false by default, right? He's not defending at first, but he can choose to defend though. There is Vucat, yes, that's at github.com/vencabot/intro_to_Python. If you go to github.com/Vencabot, you'll find the repository for this game. Trust me. Of course, Vucat, of course. Okay, so we make a monster, and we have a random choice between two monsters that's based on their name, right? They get a random name, and then based on their name, they get some random attributes. All right, so that's what we do. That's the first thing that happens when you do battle. Right, here's our do battle function again. So we made a new monster, and we populated the game state with that monster. Then we print off, a message saying, "Oh, they're approaching you. Oh my gosh!" Right, and we print off their attributes a little bit. And then we say here, while the monster and the player are still alive, right? While they both have HP greater than 0, there's the monster's HP and the protagonist's HP. They're both greater than 0. Well, then we take a player turn, right? Print a blank line. And if the monster is still alive by the end of that turn, then the monster also gets a turn. All right, so here we say here, if they're both still alive, the player gets a turn, then we get a blank line. And then if the monster is still alive, he gets a turn, then another blank line. Okay. And then after that, we say, well, listen, we know that if we're down here, we're outside of the while loop, right? Because the while code block is all indented by 4 spaces. This is all the while loop right here. So if we're down here by this point, that means that somebody had to die. Because, that means that this statement was no longer true, that both characters are still alive. So we say down here, well, if we're down here, we know somebody died. If the protagonist is still alive, then give them some congratulations, you're victorious, and then give them some gold. Right? Give them a little bit of gold based on that monster's value. Otherwise, we know that the monster's still alive, and it says that Goki has slain so-and-so Shosh. Shosh is a reference to Third Strike. When Goki beats you, that's what he says. All right, so let's go look at what it means to take the turns, right? The player turn and the monster turn. Let's go look up here at the take player turn function we have that we're calling down there. So at the start of every turn, the player stops defending, right? If he was defending on the previous turn, now he's not anymore. Then he has a choice to make, attack, defend, or item, right? So if he wants to attack, then we use turn attack. Right? If he wants to defend, we use turn defend. It's a function we defined above. And then for items, we use turn item. Okay, and if he picks something else, well, he has to pick one of those 3, right? Just tell him he has to pick one of those things. He's gonna lose a turn right now for picking the wrong thing. Nothing happens. And likewise, the monster's turn actually happens at random, right? So at the start of each monster turn, he stops defending as well. And then we say here he has 3 options for his turn. It's a list, right? It's the monster turn attack function, the monster turn defend function, or the monster turn taunt function. Then we get a random choice from that list of options for the monster's action. It'll pick one of these 3 at random. And then we use that action, right? Giving it the game state argument, like all of our functions take. So Faust, I've been playing Makoto for like 7 months and just learned about her secret taunt, huh? Yeah, there's a lot of secret stuff in Third Strike. There's kind of, doesn't really come up that often when you're talking to people, so it's kind of a surprise sometimes when you hear this kind of stuff. Python gives you too much flexibility. Yeah, it's really great. Python's very, very flexible. That's another great thing about Python, among many other great things about Python. All right, so the monster gets a random turn. The player chooses what he wants to do. And for the most part, all these functions are pretty straightforward about how they work. Basically, if you choose to attack the opponent, or it's, the monster's turn might be randomly chosen to attack the opponent, then you deal damage to their HP equal to your attack power. If you choose to defend, then on the opponent's next turn, you take half damage. And in the case of taunt for the monster, that means you just waste his turn. Nothing happens, which is good for the player. And then finally, we have the player's item turn, which is the most interesting kind of turn in the game so far. Where when you try and use an item, what happens here is you get to see a list of everything you have, which is done in a for loop. So you guys remember from last time that a for loop is a kind of loop that will go through every item in a list and do something with that item. So in our case, we're going to go through the inventory one at a time and print off what you have in the inventory. Right? Every item gets printed off onto the screen. That's a for loop, right? You do something for every item in a list. In this case, print it off. Then you make a choice from your stuff, what you want to actually use. And here we have a dictionary, an item map. And every kind of choice you can make is associated with a function in the item map. Right? So here you have the word spear that you might type in is associated with this function, item spear. And same with the TP, you have this item, this function, potion has a function, and thumb drive has a function that we defined right down here. Here's the item spear, for instance, right? So here we say, well, we're going to try to get our item function out of the dictionary by supplying the player's choice. If they punched in spear, then we're going to get item spear out of it, right? That's how dictionaries work. You have a key, which is on the left side of the colon in a dictionary. Then you have a value for that key, right? And they're separated by commas. So you have any number of key value pairs. And when you call the dictionary, like so, the item map, right? And you supply a key, right? The player's choice is going to be our key. That's what the player typed in. Then you get out of the dictionary what data is at that key. So again, if the player typed in the spear, we're using that as our key. And here in our dictionary, that has the value of item spear. It's a function. So then we're going to call that function, right? So we save the function as item function, and then we call that function if they want it. However, if they typed in a key that is not in our dictionary, if they typed in, let's say, they wanted to use like longsword, right? We have no key here for longsword. That will crash our program because we're trying to get a key out of our dictionary that does not exist. However, if we put this into a try block, it won't crash our code if we accept the error that we expect to happen, right? So here we're accepting key error. So if the user typed in something that's not in the dictionary, then we don't crash. We just print off saying, you don't have that, right? You're not carrying that item. Then you lose your turn. So you want to make sure you type in something that you actually have. Vukat says in C# or Java, it's not easy to use your function as a variable and store in a data structure. So what Vukat's talking about here is that in Python, functions are what are called first-class objects. So in some other languages, functions are strictly bits of code that you can selectively execute at will. Right? We mostly use that the same way here in Python. So we define a function, and we can call this code at will from anywhere else. That makes sense, right? That's what functions are for. However, in Python, you can store functions in dictionaries, right? Or you can put functions in a list, or save them under a different name, such as item function, right? So basically, in Python, functions are first-class objects. They are not only code that can be executed, but they are also data that you can move around. Right? They can also move this kind of data around. It's kind of cool, very flexible. Not every language is like that. All right, so that's how our program works right now. Right. So basically, we have this ongoing battle between two characters, and let's go look at our do battle code one more time here, because something interesting happens if the player survives. Right. So if the player dies, then we get a game over. Right. Because we have this while loop down here, and it says only keep on doing battle if the protagonist is still alive. For as long as the player is alive, keep on doing battle over and over and over again. But if he were to die, we get a game over, right? We drop out of the while loop. But what's cool about this is that if the player survives, he gets gold. His HP is not restored. He has to survive, with how much HP he still has left. And then do battle happens again from scratch, right? So we finish our fight down here, right? This is a celebration for beating the monster. And then we go right back to the top, where we make a new monster. And then we say, so-and-so is approaching, right? And then you fight them. Let's demonstrate our game real quick, guys. You guys didn't watch last time. let's demonstrate how our game operates. Here we are. It says, what's your name, son? I'm going to be Vukat. Okay, so we got Goki. Now, that's bad luck, right? Because we have two options we can happen. Two monsters we can get at random. Right, we made a new monster. Right up here. It can be Goki or Baby Goki, and then based on the name he gets randomly, he gets different stats. Baby Goki is very weak, and Goki is very strong. Right, so we kind of got bad luck there. We can attack, defend, or use an item. I have 10 attack power, I believe. Let's go review that real quick. Let's go look at creating a new protagonist, right? He has, oh no, if I'm Chun-Li, I have 10. Uh-oh, I didn't punch in Chun-Li. I have 6 attack power then. So he has 20 health. It'll take me 4 turns to kill this guy. That's pretty rough. If I use a spear, I can do double damage, and then it'll take me less turns, but I can only use 1 spear. I only have 1 spear to use. I don't see why we shouldn't use it though, right? Yeah, thanks for the follow, Unseen NRG. We play a variety of games here on the channel, but on Fridays it's Intro to Python, where we teach Python programming at a kind of beginner level. Hope you enjoy the show. Vukat says, by the way, when we select a non-existent item in dictionary, like longsword, we catch our error and we lose our turn. Yes, we do. Yeah, so in the future, maybe even by the end of today's stream, I would like to fix a couple of bugs in our program where, I'm going to go down here and demonstrate this, right? If I were to, let's say, try and use an item that I don't have, right? Right here, the key error. We don't actually get our turn back. We can fix that later on, but basically we do lose our turn by doing that. And same with if we were to choose an option on our turn. Let's see, where's that at? Right here. It says here, do you want to attack, defend, or use an item? Right? If you pick attack, well, that happens. If you pick defend, that happens. Item, that happens. But if you don't pick any of the above, you pick, like, let's say, run away, it'll say you have to either attack, defend, or use an item, and then you lose your turn. It would be nice if, instead of losing your turn, you got your turn back, right? You started from scratch. That'd be ideal. We can fix that later. Okay, so I'm going to use an item here, right? I'm going to throw my spear at Goki and reduce his health by 12, because I have 6 attack power, right? And the spear does double damage. Okay, so now he has 8 HP left, and he Tatsumaki me, very bad luck. Again, Goki can either attack me, defend, or taunt. And if he defends or taunts, he basically forfeits his turn, right? I get free damage on him. But if he tattoos me, that's his attack, I take a really big damage. I took 10 damage, I lost half my health, or more than half my health, right? I start off at 25, I have 10 now. So he can kill me now in 1 more turn. It'll take me 2 more turns to kill him. I have no spear left. All I can do is attack twice and hope that he doesn't attack me, right? I'm going to attack him. If he attacks me, it's game over. But if he doesn't, then I'm pretty sure he's going to die, right? He has 8 health left. So if he defends, then I can still kill him in 2 turns, right? Because he's going to take 3 and then 6 damage. Okay, so he taunted me. So now I can kill him, because I get the first turn next turn, right? I attacked him, he's at 2 health. He taunted me. I can kill him now for free. Let's do that. There you go. So I killed Goki. It says here, Vukat / Goki with his sword. Vukat is victorious. Vukat earned 10 gold. Vukat is now carrying 10 gold. Now another Goki is approaching me, right? I have 10 health left. I have a potion I can use to restore my health. Let's use that. Because he can kill me in 1 turn otherwise. I want to use the potion. So I got 10 health back by using the potion. I'm at 20 health now. It'll take him, I believe, 2 turns to kill me now. And he is covering his soft belly. So he's defending now. Right, so I'm going to do half damage next turn. But it's better than nothing. Let's attack him. I have a shot to win this, but very low shot. Okay, so yeah, I'm definitely going to be in the shit right now. He has 17 health. I have 6 attack power. It'll take me 3 turns to kill him, right? That'll be 18 damage. I have to then survive for 2 turns and get lucky and hope he does not attack me, right? He has a 1 in 3 chance of attacking me. So I can survive if I get lucky here, right? He killed me. It says, Shosh, game over, right? So I died with, 10 gold. But in a perfect world, I could have got some baby Gokis in there. I could have been playing as Chun-Li. Before, our high score was like 70 gold or something. It wasn't too shabby. Anyway, that's how our game works, basically, right? We fight a monster, we beat them, we earn gold, we fight the next monster, and see how long we can survive, right? And that's really fun. That's actually surprisingly fun for being such a simple game. But it does have shortcomings, right? Our gold has no purpose aside from keeping score. And we don't ever grow as a character, which means it's not really an RPG. We don't actually get stronger, right? I don't want to change that today. So, what we can do is, between fights, maybe let's not always, so if you look at our game code here, right? We say, while the player is still alive, then do battle, and then, print a blank line. Do that over and over and over again. Maybe instead of doing battle repeatedly like that, maybe we should actually have this player choose whether they want to fight or if they want to go to the shop. How about that? Vucat, I'm going to suggest your channel in our members of society in college. They are pretty beginners. Your explanation is very good. Thank you, Vucat. I appreciate that. Get the word out, my man. Get the word out. Share the channel. It helps me out a lot. So before we actually add a new function here, such as let the player choose what they want to do, why don't we instead fix this code right here for do battle? It's a very long function. It's a very, very long function. Why don't we have a different function here called finish battle? Right. So let's go make a function here. I'm going to say here, I'm going to say here like conclude battle. Right. We're going to supply the game state. Just to break it up a little bit because it's getting kind of long. So we've made it down to this point. Battle's over, and we're going to have this code down here for finishing a fight. Right. It's going to be its own function. So let's go down here. Say def conclude battle in the game state. We know somebody died. Right. So if the player died, if the player's still alive, he gets gold. If the monster's still alive, then it says shosh, and we're dead. Right. So there you go. I got two functions now. It's not quite as long. Do battle was kind of long before. It's all well and good. Cool beanzos. Sweet. So in fact, instead of even... Nah, that's fine. We'll leave it right there. Hugo says, when does Mortal Kombat Armageddon start? In about 2 hours. It's going to be starting. I'm looking forward to it. Alright, so we have this code here for... enjoy your nap here, you guys. For concluding the fight, right? Where we get our gold and our congratulations message, all that good stuff. That's fine. So now, how about before every fight, we have a new function, or a new bit of code that says, player choice. Let's just call this destination, right? Destination equals input from the player. Do you want to fight or shop? Right. So I have two options there, fight or shop. We're going to say here, if a destination is equivalent to fight, then do battle. Right? We're going to say here, otherwise, we'll say elif, destination is shop. Then print off, we can't do that yet. Right? And finally, we're going to say here, else, if it wasn't those two, then we're going to say, print off, you have to either fight or shop. Right? There you go. So let's run this code now. Our code's a little bit more sophisticated now. We added a couple lines there. It's very simple still, but we actually added some new features already. Let's go ahead and run this code. What's your name, son? I'm going to be Vucat again. It says, do you want to fight or shop? Well, I want to run. You have to either fight or shop. Do you want to fight or shop? I want to shop. See, we can't do that yet. Okay, do you want to fight or shop? I want to fight. There you go. Goku's approaching. Right? Let's kill him. I'm going to throw a spear at him first of all. Okay. And I'm going to attack him. And I'm going to attack him again. I'm going to attack him one more time. Okay, so I got some gold. That's cool. It says, do you want to fight or shop? So basically here what's happening is every time we start a new fight, we have the choice to either fight or go shop. That's kind of cool. So now we have options available to us between fights. So let's get the shop working, shall we? So if we want to shop, we can say, let's make a new function, right? We'll say shop. We'll call it go shopping. Right? We have a new function now, go shopping. Let's go make it do something cool. If they choose to go, if they want to shop, right? We'll do it right here. Define new function called go shopping. It's going to take the game state as an argument, and by doing that, we get all the data from the whole game, right? So basically, the way our game is designed is we have this game state dictionary, and it is saving every important piece of data about the whole game. And by using that as an argument for everything, that means that all of our functions can access pretty much all of our important data, which is a blessing and a curse. It's very convenient, but also means kind of hard to tell what our functions are doing sometimes, right? It'd make more sense in the long term for us to kind of know what our functions are doing based on what kind of data it's getting. Right? Sometimes you want to kind of control how much data each function gets. But in our case, every function gets all of our data to change and mess around with. That's, again, very convenient, but can cause problems later on. Should be MK9 instead of Armageddon. LOL, JK, dude. Armageddon's so sick, bootcamp. Welcome aboard, dude. Armageddon's so sick. Alright, so this go shopping function here, right? We're going to say, like for the follow, Lobo FPS. So are you a streamer, Lobo? Do you play shooting games? That's what it sounds like. Go shopping. We're going to print off, game state, protagonist name, right? That's the player's name, plus, walks into a shop, right? Then we can print off, the shopkeeper presents their available wares. Okay. So what we're going to do here is we're going to make it very simple for now. I'm just going to print off all this stuff, right, manually. 1, 2, 3, 4. I'm going to print off, we're going to fix this later, guys. A spear, very valuable, right? Then we're going to have that be, how about, like, you get, what, 10 gold for killing a Goki? We'll make it 15 gold for a spear. I'm going to say 15G, right? You get the idea of what G is. Then you can also buy a potion. And those only heal 10 health. We'll make that 10G. Right. So we only have 2 things you can buy right now, essentially. Then we're going to ask the player for some input, right? We're going to say, purchase, purchased item equals input from the player, right? What are you buying? Right, put a space there as well because it's an input. Makes things a little bit nicer looking. Cool, so now we can get an input from the player what they want to buy. Right? We're going to say here, if purchased item equals, is equivalent to spear. Actually, I should lowercase that to be clear what's going on here as well. I don't want to confuse the player. We want everything to be in lowercase. All right. If they want to get a spear, then we're going to say here, if game state, is it called player purse or protagonist purse? Let's go review what our gold is being stored in. Right, do battle. We actually have this protagonist purse, right? This amount of gold they have. So we're gonna say here, if the game state, the protagonist's purse is greater than or equal to 15, right? They have 15 or more gold. Then we're gonna say here, game state, player, I think it's called player inventory, right? It's not called protagonist inventory, is it? Or is it? I don't know, let's go double check. I kind of get mixed up between using the words player and protagonist sometimes. Let's see here. Make a new player. He has a player inventory. Okay. That's fine. Okay, so we're going to shopping, right? We're going to add in, with the append method, a spear. As you guys know, right now, items are just strings, right? So we're adding the string, a spear, to his inventory. And then later, if he wants to use his spear, all he does is type in the name of the item, and it calls a certain function. Is game state public? If it's public, why did you pass every function? Here's the thing, VooCat. It is public, and it's a global. It can be considered global. But by passing it explicitly, it's kind of like a reminder to limit its usage later on, right? Because we could make it global, but you really want to avoid globals in Python or any language. It can make things very complicated if you use globals. So basically, I'm passing it explicitly as an argument, right? That way you know it's being used inside that function, right? You never want to use globals, pretty much ever, if you can help it, unless it's a constant. Right? If it's a constant, then you can use it with all caps. It makes it very clear that it might be used in other functions. But if you have a global, let's say I were to put game state at the very top, and then have all these functions call it that way, we wouldn't be able to revoke access to it very easily as our program gets bigger. Right, so basically what I'm trying to say is, if your function needs access to a piece of data, always pass it in as an argument, unless it's a constant. Right? Now we'll talk more about constants later. Most of us are total beginners here, don't really need to worry about that too much. But what you guys need to know is, if your functions are using a piece of data, please pass it in as an argument. What VuCat is saying is that technically, I haven't taught you guys this yet because it's not really a good design decision. But technically, if you have defined a variable in the main scope, like right here, it's not defined in a function, it's defined in the program, right? It's not in a function, it's right here on the far left of the screen. That means that technically, every function can just use it, right? That's called a global, basically. We don't need to actually supply it as an argument, but I want to really stress to beginners, we do need to supply it as an argument. If we don't, it's going to cause problems later on in our code. Trust me. Don't use globals, ever. Always, if your function needs to have some data to do its job, supply it explicitly as an argument, unless it's a constant, in which case game state is not a constant, it's constantly changing, right? Constants are pieces of data in your code that never ever change. They never change. It's just a way to refer to some piece of data, and that way you can kind of save you some typing later on. But we're not going to worry too much about that as beginners here. Anyway, so we're going to append this the spear to our inventory, and we're going to remove that gold, right? We're going to say here, game state, protagonist purse, minus, equals game state, protagonist purse, minus 15. So this line is pretty clear what it does, right? It takes the protagonist purse, and it assigns it a new value, right? It assigns it to whatever the value was minus 15. So if this was 20, we're saying, hey, I'm reassigning the value of protagonist purse, and the new value is whatever it was minus 15. That's going to end up being 5, right? If you started off with 20. But I want to teach you guys something real quick now. In previous seasons of Intro to Python, I have not bothered teaching this. It's really what's called syntactic sugar, which means that it makes things look nicer, but it has no other features aside from that. We can make this line a lot shorter by using a certain kind of operator called minus equals. Okay, so once again, game state, protagonist purse, we're reassigning it a value, which is whatever it was minus 15, right? But in Python, you can actually do that like this. Minus equals. Okay, so here you're saying, take this value and then make it whatever it was minus 15. You can also use plus equals as well. Right? Whatever it was, reassign it with 15 more, essentially. So we're going to make this a little bit shorter by using minus equals here. It's our first time using that Intro to Python, only because that line was so long, it's a good time to mention it, I guess. But again, it's called syntactic sugar, which means that it doesn't really do anything that you couldn't have done with a longer line. It's just saves you some typing in some space. We're basically saying here, remove 15 from this thing. Right? So we're removing 15 gold from the purse. We say otherwise, if the player does not have 15 gold, just print off, you can't afford a spear. Right? We do the same thing here with the potion. It's going to be so similar, in fact, I'm going to copy paste it. Just paste it here. We say if they want to have a potion. Then we're going to say here, if they have 10 gold or more, then they can buy a potion, and they're going to lose 10 gold. Right? Otherwise, they can't afford a potion. That works. We're going to say here, what are you buying, or do you want to leave, right? So, we can say here, do you want to leave? Let's just have it, say here, if, purchased item is leave, then, just, end the code, right? We'll say return. Return means end the function. Okay. We'll even print off a message like, print game state, protagonist name, plus leaves the shop. Right, there you go. Then you return. Return means end of the function. As you guys know, return also means I can return data out of the function. I could say return game state to return some data out, or return, spear, wherever I want to return. But return also will end a function immediately. So let's say, return, end the function. Otherwise, print off, the shopkeeper doesn't sell that, right? And then we can, you know, start over again, right? We'll just kick him out, right? I'll say the shopkeeper is confused, you know, and kicks you out, right? Let's make our lives easier. There you go. Actually, we don't need return here because we're going to be at the end of our code anyway, right? The code ends right here for the function, so it'll return in any case. Here we returned explicitly that we could end the program. You know, actually we don't need that either, right? Because we're gonna hit. Oh, I'm sorry. We're gonna hit the bottom anyway, right? That's fine. Cool. If we return here, we would end the function immediately. But basically, what's gonna happen here is we're gonna hit the bottom anyway of the function and end the function anyway. So Vencabot is English is a second language. I'm going to try and read this anyway. In C# or Java, there are main classes, or you know there is a different frameworks. We use controllers like MVC controllers, and they almost don't have public items. But in Python, it's better approach, your opinion idea. So yeah, so in other languages, there are more control. There's more control over globals somewhat. And so global usage is more popular. But even then, I'm of the school of thinking, Vucat. I'm of the opinion that globals are typically a bad idea to use because they will cause bugs. After you have like, you know, 20,000 lines of code in your program, it becomes very difficult to know where some of your functions are getting their data from. If you don't know where the data is coming from, it can be hard to control it. So if you use globals a lot, you're going to be having functions having access to data that you don't expect them to have access to. So I find it's better to typically put your data you want for your function as an argument whenever possible. What's up, Vakesh? The no comment gang. No comment. We got lurkers in the chat. Welcome, Vakesh. Okay, so we have a shop here, and I think it should be working pretty well already. Here's what happens, guys. When you start a new fight, or let's say when you survive a fight, or the game starts, you're asked if you want to fight or shop. If you want to fight, we spawn you a monster, you kill the monster, you get some gold, right? If you want to shop, then this function runs right here. It just prints off, you walk into a shop, the shopkeeper wants to show you stuff, we print off some items and their prices, and then we ask you what you want to buy. And based on what you want to buy, we run a little sub routine, right? A little code block here that finds out if you have enough gold for one thing. If you have enough gold, you get the item, and you lose money. Otherwise, it gives you a little error message. You can't afford that. That's true of every item. The spear and the potion works the same way, where we find out if you have enough money first, and then we add the item to your inventory, then we remove the money. Cool. Right? And then you can leave as well if it makes you happy. You can leave the shop without spending any money. That's great. Let's run our program and see if it works. I think it will, to be honest. Let's run it. Now we can finally spend our gold we're earning, right? What's your name, son? I'm going to be Vakesh this time. Right. With an H, though. There you go. Do you want to fight or shop? Well, I want to shop. I should print off how much gold you have, huh? Let's do that first. I'll print off, print, protagonist name. If we were to say here, game state. Protagonist name plus is carrying plus game state protagonist purse plus gold. And that's actually an integer, not a string, but I get the string version of it. Like that. You guys remember that, right? You guys can't add an integer to a string. You have to make it into a string first. That's cool. I'm sorry. Let's do some hanging indents here to make it a little bit more readable. Right. There you go. Okay, so let's actually get a blank line in here as well. And then get a blank line right here as well. There you go. That'll be easier to read. Goddamn Windows 10. There you go. All right, Vakesh. So let's run this code here again. All right, so I'm going to be Vakesh one more time. Do you want to fight or shop? I want to shop. Okay, so Vakesh walks into a shop. The shopkeeper presents their available wares. A spear and a potion. Vakesh is carrying 0 gold. What are you buying, or do you want to leave? I want to buy a spear. You can't afford a spear. I want to buy a potion. I'm sorry, it says here, do you want to fight or shop? Yeah, you have to, it kind of booted me out there, right? Actually, I should make that more clear to the player. You can't afford a spear. You know, the shopkeeper, kicks you out of the store, right? Because you have no money. You're broke. I know the struggle, trust me. I know how that feels. Right, there you go. So basically, whatever you do, you only have one choice to make, right? You can only buy one thing at a time, then you're kicked out, whatever happens. Right. So do you want to fight or shop? I want to shop. Okay, I want to buy a potion. I have to rerun the program, right? I'm sorry. Let's run the program again. Okay, I'm gonna be Vakesh. I want to shop. Okay, so I want to buy a spear. Right, so you can't afford a spear. The shopkeeper kicks you out of the store. Now, do you want to fight or shop? I'm gonna go back into the shop. Okay, I have 0. I want to buy a potion. Give me a potion, motherfucker. Okay, it doesn't work. He kicks me out of the store. So I have to fight, right? I have to fight. Let's go fight somebody then. I'm fighting Goki. That sucks. He's a little bit more difficult than a baby Goki. All right, let's throw a spear at him. Okay, he tattooed me. I'm gonna die pretty quick. I'm actually using a potion here to survive, just in case. He's defending now. That's good. So I got my health back from the potion. He's defending. I'm gonna attack him while he's defending. Okay, he just taunted me. I can kill him now, right? I do 6 damage per attack. He has 5 health left. He taunted me, which means he wasted his turn. There you go. So now I have 10 gold. Do you want to fight or shop? I want to shop now. I can afford the potion. I'm gonna try and buy the spear. Okay, I can't afford it. He booted me out. I want to go back into the store. Okay, I want to buy a potion. Okay, we have no message there, I just realized, right? We got the potion, which is great, but I have no message for that. Let's go actually add that. Let's go here to our spear, and then print off, game state, protagonist name, plus, has purchased a spear. Right. Break the line. Hanging indents. Make it a little bit easier to read. Okay, let's do the same thing for the potion. I'm gonna copy paste this code here. All right, here's the potion. I print off that they purchased a potion, right? There you go. So now we know what we bought. But what's cool is that we got a potion out of the whole deal, right? So if I go here, I can actually go to the fight now again. Let's go to a fight. And I can use an item. And now I have a new potion. I used my potion last time. I have a new one now. Let's use it. Hey, it worked. See, I got 10 more health back. Sweet. Let's attack this dude while he's defending. He tattooed me. He can do that twice. 2 more times, right? He does 10 damage per tattoo. I have 15 health. Attack him again. Okay, he taunted me. I like that. Excellent. Got a free win. Boom. Got 10 more gold, right? So I can go buy another potion. I think I need one. Let's go to the shop. I want to buy a potion. There we go. Let's go fight again. Okay, but I got really bad luck. We got 3 Gokis in a row. I really want the baby Goki. He's a lot weaker. Let's attack this man. Let's use our potion. Let's actually save the potion in case we survive. He can't kill us in 1 hit, right? Let's attack him. Oh, he did kill me 1 hit. Oh, he does 15 damage. I forgot. Not 10. He did 15 damage per attack. Fuck. Well, we died. It's all right. So now we can finally spend our gold in an interesting way, right? But here's where I want to start talking about object-oriented programming. Thank you, Vakesh. Yeah, rest in peace. Rest in peace. Yeah, I forgot that he did 15 damage per attack. If we go look at his stats, right, let's go up here to our create a monster function. Right, right here. Create a new monster. Right. So if we get the baby Goki as our random choice for his name, right, he gets a random name from these 2 options, Goki and baby Goki. If we get baby Goki, then he has 8 attack power. Right? But if he's adult Goki, he gets 15 attack power. That's 15 damage per tatsu. So I forgot that I died there. You should add shop item to a dictionary instead of making an if. Exactly, Vakesh. I totally agree. But what we're going to do before that is we're going to make our first ever objects. Right? We're going to make our first ever objects, our classes. Right? So basically, if you look at our code here for the shop, Vakesh points out that it's very inefficient. We have a lot of wasted lines. Right? And by wasted lines, I mean that we are kind of doing things redundantly. As you can see here, the code for buying a spear and buying a potion is pretty much exactly the same. So why are we wasting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines doing the same thing again? All that's really different is that the name of the item is different, right? It's a potion. And the cost is different. It's 10 instead of 15. So what we can do is the same thing we did up here. Right? If we go back up to our player turns, let's say that we want to use an item. Right? Let's go up here to the turn item, right? We have this item map that saves us a lot of if, elif, trees. Right? Basically, we say that the word spear is tied to the function item spear. And the word potion is tied to the function item potion. And then whatever you type in, your player choice, that's what you get out of that dictionary. Right? It's kind of convenient. But we're going to actually go another step even further by utilizing objects, using classes for the first time here in Intro to Python Season 3. And what classes are is they're a way to organize data and operations. We talked about that before, right? Every program is made up of two things: data and operations. You can actually organize your variables and your functions underneath this umbrella of a class or an object, and it makes your code a little bit more organized. So you can think about things like what kind of functions might need to happen to an item. What kind of data might be used to describe an item, right? So let's actually make that as our first class. Go up here, class. We're gonna call this thing a usable item, right? So all of our usable items are going to be a part of this class, essentially. Yeah, I'm glad you're enjoying it, VooCat. I'm doing my damnedest here. It's kind of some abstract concepts, guys. I apologize if things are a little bit confusing. This is episode 4 of Intro to Python Season 3. If you guys want to go back to doing some much more basic ideas for total novices, go to youtube.com/Vencabot archive, or just search on YouTube for Vencabot. You will find a playlist called Intro to Python, where you can go watch Intro to Python Season 1 from start to finish. That's where we start off doing a Pokemon game. And day 1 is total beginner concepts if you're totally new to programming, like you've never programmed before in your entire life. And then, of course, by episode 6, which is the end of the season, we've introduced some more advanced concepts. And then also, we also have Intro to Python Season 2 on there, half of it, where we talk about making an adventure game like Zork. Like, it's more like a kind of a puzzle game. And then this is, of course, Intro to Python Season 3. On our first day, we talked about very basic ideas. And here on episode 4, we're talking about classes, finally. It's a very important topic, I agree, VooCat. OOP, or object-oriented programming, is very important. So, we have this class, right? And it's going to have some attributes of the class. So it's going to have some variables, right? We're going to say here, let's say it's going to have a cost, right? I'll call it gold cost. And, by default, that's 0. And it's going to have a name. We'll call it like an item name. And that's going to default to like, item. Right, we'll change that later. And so we have to have a function, right? We'll have it like do a thing. So we'll say, we'll call it use. Right? We'll call it use item. Right? And by default, all it will do is it will just print off, you used, plus item name, right? Plus a period. So basically, this is a very, very simple item right now. It has a gold cost, it has an item name, and it has the ability to be used, essentially. Yeah, because you don't actually have to inherit from object. Right? In Python, that's optional. In fact, you shouldn't do it because it wastes characters. But yeah, so we're going to talk later about inheritance, guys. What inheritance does is it will take the properties of another object and bring that into your new class, which is really cool. And in some other languages like Java and C++, you oftentimes have to inherit from the most basic class explicitly. Right? You have to kind of do that explicitly. And in Python, though, it's implied, if you don't actually include a inheritance clause there, that you're inheriting from object. So yeah, definitely, guys, never do this. So like Vikesh says, there's kind of like an old school train of thought. At one point, that was very common to do, but it's considered to be a waste of characters. If you're going to be inheriting from another class, that's great. If I was going to inherit, from some other class, that makes sense. That's very important. But if you're inheriting from object, like all classes do, just don't bother, because it's implied that it's inheriting from object. Thank you, though, for the reminder, Vikesh. That's important that people know that. All right, so we have a class, our first ever class. And here's what it's all about, guys. So classes, they have their own variables. We've talked before about variables, right? Like if you go down here, we have a variable, game state, right? Very simple. You guys know that by now, I hope. And but classes have their own variables that are under the ownership of that class. And these are not called variables anymore. Oh, they are. They kind of are. But they're also called attributes. So an attribute is a variable that's attached to an object or a class, right? And likewise, we have a function here, right? We have a function. But as you can see, it's kind of unusual. It takes an argument called self, right? And that's because it's not just a regular function. It's a method. And a method actually has access to all of the objects, or to all of the attributes of that object. So as you can see here, I can actually access self.itemName, right? Because self represents the object itself. Exactly, Vukat. Yeah, it's still inheriting from object, indeed. Yeah, so basically, in Python and in most languages, any class will inherit from the most basic class of object, right? You just don't have to type it anymore. So a dat1dud says, I appreciate how much you are explaining. Wish it was on C#, but Python's pretty close. Yeah, both are object-oriented. Thank you for the follow, dat1dud. That one dude. Dat1dude. Yeah, I know Python's my favorite language. I've actually never fucked around with C# that much. But my history is in Java and C++. And now I use Python pretty much exclusively. It's a beautiful language. Anyway, so yeah, so you're still inheriting from object. This, this code right here is the exact same as if I typed this. Either way, you're inheriting from object, but in Python, that's not necessary to inherit from object. Okay, yeah, by all means, Vukat, yeah, share something if you want. Okay, so we have a new item, a new class that has attributes, gold cost, and item name, and it has a method, right? Methods are a special kind of function that are under the ownership of a class. Right? And by being owned by a class, we can use this, we have to use this self argument, which refers to our object itself. So we can say things like, self.itemName. So it knows what its own name is. Right? That's kind of cool. It's very useful. I'm going to show you guys more about that later. So basically, we have this new object. Right? Let's make one and use it. So very simply here, I'm going to kind of comment this code out for now. Our game is going to not work anymore. This code is now being commented out. It's not going to run. But instead, we're going to kind of show what this item is all about. This new item we just made. Actually, I'm going to undo and show what I just did right there. There we go. I'm going to show you guys what this new item is that we made. So we're going to say here, test item is a usable item. Okay. It does inherit automatically. Most companies' syntax policies require you to specify. Oh, really? Is that true, Vikesh? Wow. I didn't know that. I found that very surprising. It's kind of against the rules of PEP 8 to specify to inherit from object, I believe. Anyway, so we're making a usable item. And now we can say here, print test item dot item name, print test item dot gold value. That's what it's called, right? And then we can also run test item dot use item. Okay, so our program right now, we've kind of commented out our main game. The main game will not run right now due to these little pound signs there. Instead, we're kind of using our test item, right? We have a test item, we're making it of the usable item class. And now it has these attributes, item name and gold value. And it also has this method now, use item. Let's see what happens here. Oh, sorry, it's gold cost, not gold value. I'm gonna call it gold value instead. Okay. All right, so let's rerun our code. Okay, cool. So here's what's happening, right? It prints off the word item, it prints off the number 0, and it prints off you used item. Right. So let's go see why that is. As you guys know, in Python and most other languages, a period implies ownership, right? So we're saying here, print off test items item name, right? So the period is kind of like in English, that's an apostrophe S, right? It means ownership. Print off test items item name. In Python and most languages, that's a period. Right? So this value item name, it's owned by test item. And by default, the item name is item. Likewise, there's an attribute called gold value. Right? We want to print off test items gold value. And then we have this method, right? This function, use item, is under the ownership of this object. So we have this use item method, right? It's a function that's under ownership. It means it's a method of our test item. And all it does, it prints off you used and then that item's name. Right? Cool. So that's what happens here, right? We print off the item's name, which is item, and its gold value, which is 0. And then we used it. It just prints off a message, you used item, right? But here's what we can do. Also, we can say here, we made a test item, right? We can say here, test item dot item name equals, longsword, right? So we are actually reassigning this attribute, item name, to a new value. Right? So now let's see what happens. Okay, let's rerun this code. So it says here, longsword gets printed off, 0, and then you use longsword. Right? So as you can see here, we changed the item's name after we made it, and then we also printed off its name. It got saved clearly. Its gold value is still 0. And then when we tried to use it, it actually printed off, you use longsword. Right? That's because if you go back up here to our method, use item, it references its own name. And we changed its name. So our method behaves differently now, based on that value of based on that attribute of the object. So let's talk real quick about how this object is instantiated. Okay, now what the hell is instantiation? Let's go down here and look at it. Okay, right here. So we know that usable item is a class, right? It is not itself an object. It is like a mold. Think of classes as like a mold for objects, right? And you can make objects from that mold. Okay, so used item is a class, right? Usable item is a class. And we define that class up here. Here's our mold, right, or our class. Right? Now let's say I want to make an item from that class, or manufacture an object from that mold, right? What you do is you instantiate. It's called that because it's an instance of that class. You're making an instance of that class. Right? So now I have a new item, test item, that's made from the mold of a usable item. We have made an instance of that class. We have instantiated that class. Right? Instantiation. The verb to make an instance of is called to instantiate. Right? So this is instantiation. I know it's kind of, even for a native English speaker, that's kind of unusual. Right? It's kind of a strange word. It basically means to make an object from a class. That's instantiation. So when you do that, you basically call it like a function. Right? You put these parentheses at the end of the class name, and that will make you a test item. Okay. So as you can see here, we've made a new instantiation, a new instance of this class, test item, and now it has an item name that we can change, and it has a gold value we can also change or print off or whatever, and we can use its methods. Right? We can use a function that's attached to that object from that class, and then that method can call on the attributes of that object. Now, as you can see here, we have defined no arguments, right? There are no arguments here, right? There's nothing there, it's just empty. And yet, when we defined it up here, we defined it with an argument, self. That's because all methods, all functions that are attached to classes, they implicitly take the self argument as an invisible first argument, right? So you define it here, but you don't actually have to call it when you call the function or the method, right? You still get access to self, though. As you can see here, we're using self to get this attribute, item name, right? So that's really true of all methods. That's the power of methods. The power of a method is that it has access to the object that it is attached to. In fact, this is not our first time using methods, right? This is our first time making a method, but we actually used them before. If we go down here to our shop, for instance, right? Let's go back up here to our use item, right? We made this a long time ago, this use item function. Right? Turn item, right? We say here, if you want to use a potion, then we run this code for using a potion. Right here. As you can see at the very end of it, it says, get the list, right? The player inventory. That's a list, right? And then we remove the potion. So what is this doing exactly? Well, it's actually, remove is a method of anything of the list class, right? So lists, you have this remove method that you can supply an item, supply some kind of data, and it will remove that data from the list if it has it, right? So typically, how we've looked at functions in the past, like this function right here, for instance, right? It doesn't have access to any data that's not supplied explicitly as an argument, right? So in that case, how does remove know which list to remove potion from? Right? We're not supplying the list as an argument. There's no, it would be like, there's no list here, right? There's no list. How does it know which list to remove potion from? Well, it's easy. It's a method, right? It removes the potion from the list that it is owned by, right? It gets this implicit self argument we don't see, right? So basically, remove will remove the argument from the list that it is owned by. Right, look at we use choice as a method, right? Let's go up here to our random.choice. Let's go up to when we're making the monsters, right? Create new monster. We have this random.choice. This is not strictly a method because it is random is not a class. Random is a library, right? So you can think of this as more like an owned function, but even then, it has access to the constants, if nothing else, of the random library. So basically, by having ownership here, it's kind of getting some data invisibly. Right? It can be very useful to think of it that way. So up here, we've used methods before, but here, stepping from a random class? Oh, maybe. I don't know for sure. I know most libraries, sometimes they do that. Anyway, so we've defined our first method here, the use item method of a usable item class. And all it does right now is it prints off you used such and such item, right? So why don't we talk more about instantiation? As you can see down here, we could define our objects very simply by saying, like, here's a long story, right? I could say, how about test item dot gold value equals, it costs 100 gold, right? Now I can print off, I can run this code again, right? And it'll print off that it costs 100 gold, right? That's great, that makes sense. But we can also use what's called an init method to initialize any object that we choose to make. Okay, so watch what I do here. Instead of making a usable item, I'm going to instead make a spear. Right? I'm gonna call this a spear item. I'll call it an item spear, right? I don't know. I kind of like spear. I'm sorry, guys. Let's call it spear item, right? So it's a spear item, right? And we know the spear costs 15 gold. And we know it's called a spear. Right? But what we can do is, instead of defining it that way, how about we do it like this? We'll call it usable item, like before. And we're going to define a new function. Def underscore underscore init underscore underscore. We're say self. That's good enough for now. Self dot gold value equals 0 by default, and self dot item name equals item by default. Right. So let's talk about what this is doing here. So when we call this function here, as you can see by this syntax, usable item, by calling these, putting these parentheses on the end, we are calling a function. But usable item is not a function. It is a class. Right? So how can you call a class? You don't call a class, right? You instantiate it. Well, what's happening here, guys, is behind the scenes, Python is calling a function invisibly. It's a magical function, and like any magical function, it starts with 2 underscores and ends in 2 underscores. And we're at liberty to change this invisible function. So when you instantiate any object in Python, any class, it will call that class's init method. We're redefining that here. Right? So now we have a function that's called when we make a new object of this class. And all it's doing here is taking self, like any method does, and changing these same values. Now what Vucat says in the chat is very interesting. He says, is gold value and item name attributes are class or instance attributes? So basically, the class itself can have values that are a part of that overall class. Right? If I define them up here, gold value is 0, item name is item, like before. These values are indeed attached to every instance that's made of this class. But not only that, they are defined when the class is defined. So they are sort of like shared. That's not really fair to say. It's kind of confusing. They're kind of like shared between all objects of the class. But it's kind of confusing because you can redefine them and they become instance attributes. Right? So really that becomes a problem with mutable data. We'll talk about that more later. Don't worry about that for now, guys. What I really want to stress is that usually you don't want to define attributes like this. I wanted to define them like this to make it simple at first for you guys. But typically you want to define your attributes in the init function. We'll talk more about why that is later. It has to do with the idea that Vucat put forward of class attributes and instance attributes. They are a little bit different, but they're mostly the same. But those differences can kill you later. Right, so basically, we're redefining our init function here, right, to supply these attributes to our function. So our function should behave, our class behaves exactly the same way as it did before. Right, we can run this code here. It'll still work fine. Right, long sword, 100 gold is what it costs. Right. What we can do now is, because we know that init is an invisible function, it's a magical function. Like any magical function, it actually starts off with 2 underscores and ends in 2 underscores. That means that we don't see it being called, but it's being called. Right? Because init is a method, it can, like any function, take arguments. So let's say here, I want to supply item name. I want to supply gold value. Right? What does that mean? Well, we have arguments, like any function has arguments, right? And now we can use those arguments in our function. So we can say here in our method. So self.itemName equals item name. Self.goldValue equals gold value. So here we're going to be saving some lines. I'm going to show you guys why we're saving lines. Because now, when we are making our instance, when we are manufacturing our object from this mold of a usable item, we are supplying an item name and a gold value. And then the init function saves those values as attributes of itself. Right? So it's going to get in this item name as an argument, and it's going to save that item name as an attribute of itself. Okay, watch this. Previously, we defined the item name and the gold value after instantiating the item. But now it's going to need some arguments here. Let's supply them as arguments. Longsword and 100. There you go. So as you guys know, by instantiating usable item, we are actually calling the init method of the usable item class. Right? Even though we don't see that here, we're actually doing this. Right? We don't see it though. That's what we're doing. We're calling a method. That method takes 3 arguments. It takes self, it takes the item name, and it takes the gold value of that item. Right? But self is an invisible argument of any method. So we don't supply it. We don't supply it explicitly. We don't do that. Right? Self is always whatever the owner is of that method. That's fine. So it's applying only 2 of the 3 arguments, longsword and 100, which is the item name and the gold value, right? So what's going to happen here is we're going to call init with these 3 arguments, right? You only see 2, but there's 3 there, right? The first argument of a method is always self. So we're calling init with these 3 arguments, self, longsword, and 100. Let's go review how init works. The first argument, item name, is being saved as self.itemName. And the second argument, or say the third, gold value, is being saved as self.goldValue. Okay, now watch this. If I run this code, it's going to do just what you think it's going to do, right? Let's just run it. It works the same. It prints off longsword 100, and you use longsword. So by making this item right here, and supplying these arguments, we can now print off its item name, and print off its gold value. And then the useItem method can also reference that item name or gold value. Right? So it actually, in the init method, it's saving these attributes, item name and gold value. Okay, cool. That's great. So now we can actually do some cool stuff. Right? Why don't we actually add another argument? It's going to be, the use function. Right? We're going to save that as another argument here. Self.useFunction equals useFunction. Now we talked before about how functions in Python are first-class objects. Right? So they can actually be used as arguments, they can be used in lists, they can be used in dictionaries, and here we're going to be passing in a function to use this item in question. Right? Now if you look at the spear, for instance, right? We have this spear down here. And the spear is a function that uses that spear. Right? If spear is in the game state, then, do all this stuff, blah, 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 blah. That's great. So I'm probably going to need to know what game state's part of. I'll give it the game state as well. So now when you make a new usable item, it's taking 5 arguments. It's self implicitly, the item name, the gold value, the use function, and the game state. So basically every item has to know these 4 things, right? It has to know the item name, the gold value, the function for using that item, and the game state. Right? Cool. So, let's go make a spear. We have the spear here, right? We're going to be a usable item. We're going to call it a spear. The spear is worth 15 gold. Its use item is, as use function, is item spear, right? So review that, make sure I'm correct. So to use the spear, you call this function, right? Right here, item spear. To use the spear, you call this function. And then we have to know the game state for the item's going to be part of, right? There you go. But we don't have a game state quite yet. That's fine. So, let's save this. Get rid of all this stuff for now. Oops. Okay. Get rid of all this stuff here. Okay. So, why don't we now make the game state and do its thing? We're going to go to the that's whatever. We'll just, use this data later on. So we're supplying this item spear function, right? Let's go up here to our, usable item. Well, is that a better idea? Let's get rid of game state. We don't need that, right? Here's what we're going to do. We're going to call the use function explicitly as an attribute of our usable item. I'll show you guys what I mean by that in a second. So now we're going to be changing the way our entire game deals with items. From now on, so previously our items were just strings, right? Our player inventory had these strings such as spear and potion. And then we were going to use those items based on a dictionary. Let's go up here to our use item code. Right? And that dictionary would associate that string with a function. Makes sense, right? However, as we add new kinds of items to our game, let's say we want to add in, a whip, or we want to add in, a bow and arrow, or whatever, right? We want to add in all these cool things. We're going to need to kind of update this dictionary all the time. And it's going to be a huge pain in our ass eventually. So what we're going to do instead is now we're going to be thinking of items not as strings that we're using a dictionary to associate with functions. We're going to think about them as their own objects, right? They're going to be items now that have attributes such as an item name and a gold value and a function that will use that item, right? So let's reimagine now how the inventory is going to behave, right? So first of all, let's go to when we make our character, right? Let's go here to our character creation. Create new protagonist. Here's where we're making the inventory. Right now, the inventory is filled with strings: spear, a roll of TP, a potion, and a thumb drive. Let's reimagine how this is behaving. So I'm not thinking about adding strings to a list, right? We're thinking about adding usable item instances to a list. So I'm going to say here, let's get rid of all this. I'm going to say here, I'm going to add in a usable item. It needs an item name and a gold value, and also it needs a use function. I'm not sure why it's not updating here. But yeah, I want to use, the item name is going to be a spear. Its gold value is 15. And its use function is going to be item spear as the use function. Right. Hey, what's up, Steve? It's going pretty well, dude. We're getting some kind of more abstract concepts here. I feel like I'm having a little bit of trouble making them explicit, how they work. But hopefully people are kind of keeping up. How's your day been, homeboy? So now we have this inventory of our character. It has one item in it, right? And no longer is that item just simply a string, spear. Now this inventory contains one item, which is itself a object. And the object's name is spear. It's worth 15 gold, and it has a function for using it. An item spear. Right? Cool. Let's do the same thing for another item. Usable item. Potion. You know, it costs 10 gold, and its function for using it is item potion. We defined that function earlier. Right. We also have a usable item. It's a roll of toilet paper. It costs 5 gold. Look, it costs 2 gold. And its function for using it is item roll of toilet paper. We also have a thumb drive. I feel like I'm forgetting something here. And its worth is, we'll make that worth like 20 gold. And its function is item thumb drive. What am I forgetting? Don't we have another kind of item? Or do we not? Potions, TP, and a spear. We only have 4 items now. That's cool. So we just put in one of each item into our inventory. And now these items are going to be able to behave differently, right? Because now each item is saved with the function that's used to call it, as well as its name and value. Right? So we have these objects now, these instances of usable item, and we can access their names, their values, and the function used to use them, all just from knowing what that item is, basically. They're attached to that object. So what does that mean now? Well, it means we can go up here to our use item, right? Our item turn. I think it's called turn item, right? Right here. We don't need this dictionary anymore, because now the actual objects we have a function attached to them for using that object. Okay, so it says here, for every item in the game inventory, or the player inventory, right? It's no longer a string. We can't just print off inventory item, because this list here, the inventory, is no longer filled with strings. It's filled with usable item instances, right? So we actually need to call this as inventory item dot item name. That's the string, right? So for every inventory item in the inventory, print off 4 blank spaces, and then inventory item dot item name. Okay, cool. It says here, which do you want to use? You can punch in a string, right? So we're going to try, this old way was to use a dictionary. We had a dictionary that we punch in our player's choice into, and that's kind of how we did that. But instead, we're going to say here, well, here's what we're going to do, actually. Because we're still using strings to access our inventory, because we're actually using a text-based interface, right? We're doing like a text-based game. The player can only type in strings. How about as we go through the inventory, we make a new dictionary, right? That contains all the items that the player has in a dictionary. Let's go make it like a, I'm gonna say I feel like a, inventory dict, and it's going to be an empty dictionary at first. We're gonna say here, for every item we have, print off what it is. And then we're gonna say here, inventory dict at the value of inventory item dot item name. I'm going to assign that to this inventory item. Right. So that way we're saying we're making a dictionary, and we're saying here for every item we have, put it in the dictionary, add its name, and then give me the item back that that name is attached to. Right. So the key is the name of the item, and the value is the item itself, which has a gold value. It has a use function, importantly. So what do you want to use? Well, the item function is going to be the item inventory dictionary. At the player choice, so we're getting back the actual item itself, the item instance, the usable item instance, and the function is going to be its use function, right? Because every usable item instance has a use function attribute, which is the function for using that item. Right? If you go back to when we made our inventory, you can see that we defined this use function for every item we made. Right? These are all function names, as you guys recall. For instance, we have the thumb drive right here, right? These are all functions. Cool. So let's go back to our turn item right here. All right. So basically, we have this same behavior as we had before. However, now we are treating these items as objects in Python. We're using object-oriented programming. We're using attributes. We are having these inventory items which have themselves many properties. Right? They have their own item name, their own gold value, and their own use function. Right? We're defining it when we create them. So what's really cool now is that when we have like a shop, we can give the shop its own, like an inventory essentially, right? And then it can kind of give you items that it has in stock. Right. So let's go down here to how we're going to use these. Well, first of all, let's go back to our spear. Because we see we have a problem, right? Let's go up to our spear. Our turn spear, right here, the item spear. So right now we're going to be removing the string spear from the inventory. And we're checking to see if the string spear is in the inventory. But again, we're not storing strings anymore, right? We're storing these objects. So instead, we're going to say here, we have to make like an item map again, right? We're going to say here, inventory dict equals, we're going to fix these problems later, trust me. It's kind of like we're kind of dancing around the idea of making these use items their own method of the usable item class, right? That's because we're going to talk about inheritance later. But for now, we're going to say here, we're just trying to use the spear, right? We're going to first of all see if we have the spear by making a dictionary, right? Let's say for inventory item in game state player inventory. We're going to say here inventory dict at the key of inventory item dot item name. Save the inventory item. Right? So we're making the same kind of dictionary we made before, where we have a big dictionary now of item names to inventory items, right? The name of the item and the item itself. Now we're going to say here, if spear is in the inventory dict. We talked before about how the in statement could be used in lists, right? To say, if this item is in this list, then do this stuff. Well, what's cool about the in statement is that it also works with dictionaries, and it uses the keys, right? So we're saying here, if the inventory dict has a key of spear, then do this stuff. right? We could also just use a try and accept block. It might make even more sense. This code will work, right? It says here, if we have a spear, then do this stuff, right? If spear is in the inventory dict list of keys, then run this code. But we can also just try, like we do like a try and then accept key error. Let's just do it this way though. Right, this works fine. Do that for all of our items. Right, so I'm actually going to copy this code here and use that for all of our items as a way to figure out what we've got. So we're saying here, if the player has a roll of TP, we're going to change that code to be like this. Right? Make a dictionary of what they've got, and then if it's in there, then use it. Same for the potion. Right. Make a dictionary first of all the stuff that you got. And then we're going to make sure that you've got the potion. If you do got it, we gotta remove it later. And same with the thumb drive, although it doesn't really matter with the thumb drive. That's fine. So let's go up here now to our spear and make sure that we're removing the correct thing, right? So if you look down here now, we have the player inventory dot remove the string spear. We're not removing a string, we're removing an object now, right? So that means we have to use the dictionary that we just made. We're going to use inventory dict with spear. Right. And same with the roll of TP. Right. We're going to remove the inventory dict at the value of roll of toilet paper. And then also down here for the potion. We're not going to remove the string potion. We're removing an actual object now. It's going to be at the inventory dict we defined up here. We're removing the item that's at the value of potion. Okay. Cool beans. So now I believe our items should all work. Let's go try that real quick. Make sure I have no typos. I probably have a typo somewhere. Let's actually we have to make the game run again, right? Let's comment out our test item. Let's just remove the test item, right? Got the idea already. Let's uncomment all of our game code and make the game run again. There you go. Now the game's running again. Let's see if it will actually work. I changed so much code at once. My name is going to be Overlord Steve. I want to fight. Okay, so it seems to be working so far. Can I use the spear? Item. So it's still printing off my names correctly. Let's try and use the spear. It worked. Let me try and use a potion. Okay, I lost the spear. That's good. Let's try and use the potion. Okay, so everything still works fine. So what we've done now is we have changed our old code where the player inventory was just a list of strings of the item's names to being a list of usable item objects. And each of those items has a name, and it has a gold value, and it has a function used for calling, for using that item. Right? So that's cool. Let's go to our shop now. Right? We have this shop, our go shopping function right here. And what we do if we do this, it actually puts a string into our inventory, which we don't want anymore, right? It's just adding in this spear string. So why don't we, instead of doing that, manufacture a spear for the player, and we will sort of give them that spear that we made for them, right? So we're gonna say here, make a spear. We're gonna say here, sold item equals a new usable item, and it's going to be called a spear. It has a value of 15 gold. And its use function is called item spear, right? And we're going to append this sold item to the player's inventory. There you go, and subtract some money from them, right? Cool. Then we're going to say here, we have this potion, same thing, right? We're going to say here, if they want to type in a potion, we'll then give them a potion, right? We're going to say here, sold item equals a usable item. It's a potion. It's worth 10 gold. and we're calling in the item potion method function to use it. Right? We're going to append that sold item to that list. So now we can buy potions and spears. And every time we buy one, it makes us a new item and sells it to us, right? It makes sense. But I want to use the power of our objects to make this code way simpler. As you guys can see here, we have these big blocks of code that are basically the same thing, right? The only way they differ is in the item's name and its value. Right, because we have the item name is a potion, whatever. We have this value of 10. It's all well and good. So instead of doing things this way, why don't we just manufacture some objects, put them into a list that the shopkeeper can sell you, and then make a subroutine that makes selling possible. Here's what I'm talking about, guys. So let's make a. We go to the go shopping function, right? We're gonna make an inventory for the shopkeeper. I want to say here, shopkeeper, okay, shop inventory, right? Every time you go here, it's going to refresh inventory. It's going to be a list of usable items. So we're making a usable item spear to sell. It's worth 15 gold, and it uses item spear as its use function. One more Templar. It says 15 gold. Inflation on the fucking spear economy, dude. And we're also going to sell a usable item potion. It's worth 10 gold, and item potion's what uses it. Right. There you go. I'm actually going to do some hanging indents here, because this line is real long. Let's go out here, knock it down. Then knock this down here as well. There you go. So now the inventory has 2 items. It's a brand new spear and a brand new potion. Every time you enter the shop, you get a brand new spear, brand new potion in stock. That's great. So now we're going to say here, the shopkeeper presents his available wares. But right now, we're printing them off literally, explicitly, painstakingly. Let's get rid of this fucking code and have it be dynamic based on what the shopkeeper has in their inventory. So we're going to say here, for inventory item in shop inventory, print off, 1, 2, 3, 4, right, 4 blank spaces, plus this item's item name, plus a colon, space, plus the string version of that item's gold value. Right? Easy. How come I can't drag this over? That's so frustrating. Whatever. Okay, so let's do some indenting here to make it a little bit easier to read. Some hanging indents, so it's not going off the edge of the page there. There we go. So what's happening here now is that for every item, which is an object now, it's not just a string, it's an actual fully fledged object with its own attributes, including an item name and a value and a use function. For every item we have in the inventory, we're printing off what its name is and what its value is. Okay. Then it says here, well, what do you want to buy? Right, what do you want to buy? And we're going to say here, that we're saving this purchased item value from the player's input, right? So we're going to make a dictionary now. In fact, when we do that up here, let's just make the inventory itself a, we'll give it some, we'll give it a spear, right, like that. And the potion, like that, right? Cool beans. So we're saying, okay, if the item you want, we're going to use this dictionary we made, right? We're going to say here, player's choice is this string, right? The player's choice is this string. And we're going to say here, if it was leave, then just leave, right? So we're going to say, if, player's choice is leave, then just have them leave. Right? They left the shop. No big deal. If that's the case, just return. Just end the function right away. However, if it wasn't leave, then we're going to just say that purchased item equals the shop inventory at the player's choice. Excuse me, at the player's choice variable. So we're saying here, if the player typed in the word spear, then we're going to be calling, we're going to be referencing this object, right? This value of the dictionary, because spear is the key. Thank you for the follow, toker ah. Maybe toker sa. Maybe tokers, sorry. So, we have this dictionary here that shows the shop's inventory, and it's paired up with the name of the item against the actual item itself, right? If I typed in spear, then they get this shiny new spear we just made. If they type in potion, they get a shiny new potion we just made, right? But now we can unify this code down below by saying here, okay, I'm gonna get rid of this code here. We're gonna say here, if game state protagonist purse is greater than or equal to the purchased item's gold value, right? So if they have enough money to buy what they asked for, then we're going to say, game state, player inventory, dot append the purchased item, right? So they're going to get the item they wanted, and then we're going to say game state protagonist purse minus equals purchased item dot gold value, right? So, and then we can actually add the item, add the little message here as well to the player. Print off, game state, protagonist name, plus has purchased a plus purchased item dot item name plus period. Right, there you go. So by using objects, we have neutralized all of this code down here, basically. Right? Boom. We're going to say here if they can't afford it, though. Right? We're going to say else if they can't afford it. Just print off, game state, protagonist name, plus can't afford a. I'm sorry. Let me actually break the line here more coherently. Can't afford a, whatever they wanted to buy, basically. Purchased item dot item name. There you go. They can't afford it. Print, the shopkeeper kicks them out. Like whenever you try and buy something, you get kicked out of the shop, right? Whenever you do something, you only have one command in the shop, then you have to leave. Basically, is the way our code works right now. And if they want to try, let's say they want to try and buy something that's not in the shop, right? They want to try to buy something that's not in the shop. Let's say that they want to try and buy a, bow and arrow, right? This right here will crash the game, because that'd be a key error in our dictionary. Let's just say here, try to do this. We're going to say except key error. So if they punch in the wrong kind of thing, we can say here print off. The shopkeeper isn't selling that. You leave the store. Right, there you go. John says, if first item is leave, needs to be just if. Yes. Thank you. Thank you for the reminder. Thank you, John. That's, you saved my life right there, dude. Yeah, so I copy-pasted that code earlier, guys. I copy-pasted that code, and before, of course, it had a previous if ahead of it. But that would have definitely been a syntax error. Thank you, John. Welcome aboard, John. Okay, so now if they get a key error, they leave the shop, as you'd expect, the way it works right now. Then we're going to say here, if they didn't actually crash out, right? We're going to say here, just return, right? So if they made it down this far, that means that we didn't get a key error, and we can actually use our purchased item, right? We got from here. Now, of course, we could do the other thing and just have it be else. We could actually say try except else like this. Let's see here. Else run this code. Right. But the thing about that is that it means a lot of extra indenting for us. Right. There you go. So this code will work just as well. In fact, in the past, we've done our code this way. So we try to get the purchase item from the shop inventory dict. Right? We try to do that. But we might get a key error if the user types in the wrong thing. Right? So if you get a key error, we'll then print off, you can't do that, and then you leave the store. Otherwise, which means, if we did not get a key error, then go ahead and keep going. Just go ahead and do your thing. Right? And that's sensible. It makes sense. It works. But a trick of the trade is that if you don't want to have all this extra indenting to make things more readable, to make them more left aligned, you can actually get rid of this else, right? Get rid of the else here. Unindent your code. Like this. Thanks for the follow, Loop 10? Loop 10? Welcome aboard, dude. Unindent the code there. And then in our accept block, just have it return. End the function right there. Right? So what you're saying here now is if the player wants to leave, then print off, you leave the shop. And then end the function, if that's the case. If we're down here in the try block, we know that we didn't want to leave. Because if we had, we would have ended the function. Right? So try to get this item from that dictionary. And if there's a key error, then print off, okay, he's not selling that, leave the store. And then return, end the function. If we're down here, we know for a fact that we did not get a key error. If we got a key error, we would have returned. We would have left the function, right? If we're down here, then we have a purchased item for sure. Let's utilize it. Again, the alternative to that would be to use a try except else block. Just like with the leave we have here, we could have used if they want to leave, then do this. And we could have said else, right? We could have said else do all this stuff, right? I could have indented it even deeper, like that. That would also make sense, right? If they want to do this, else do all this stuff, right? But we're saving on indenting by actually returning here. If they want to leave, then end the function. And if they don't want to, leave, then the function keeps going. There you go. It's a trick of the trade. That can save you some indenting there. Anyway, so if we get a key error, then the function ends. Otherwise, we have our purchased item, and we can use that item's attributes to carry on with the sale. All right, so there you go. So here's how our shop works now, guys. So basically, when we go shopping, we define a new dictionary, which has the items' names that are there for sale, next to a brand new item we're manufacturing that meets that criteria. Right? So we have a spear on the menu, essentially, and then we're making a new spear, at that value in the dictionary. We have a potion key in our dict, right? It's called potion, and we're making a potion in that spot to sell. Right? Let me print off. You walk into the shopkeeper shows you what they got, and then for every item in the shop inventory, dot values. Right? So for every, we'll use the keys, right? So we talked before about how when we use in for a dictionary, it actually goes through the keys in that dictionary, right? So for every inventory item key, I'll call it item key now, right? We'll do that. For every item key in the shop inventory dictionary, we're going to print off, the shop inventory at that item key. So this item we're getting back from this key, its item name, as well as its item value. So the shop inventory at that item key is gold value. Right. In fact, let's make it even more overt what we're doing here. Let's actually save this as like, our inventory item equals the, shop inventory at the item key, right? Now we can just go down here, we can just say here, we know the key is the item name itself, right? We're gonna say here, print off the item key, plus that, plus the inventory items gold value. Maybe let's put that in one line now, right? There you go, kind of. Okay, so, excellent. So we print off every item we have in the shop and what it costs, basically. Then print off how much gold the player has. And then they can actually choose what they want to buy, right? Or if they want to leave, that's fine. If they want to leave, then it ends the function right there with the return statement. Otherwise, we try to use what they typed in as a key in the shop's inventory dictionary. So if they want to buy a spear, that's great. Want to buy a potion, that's awesome, right? We have items that we put in stock here at those keys. Spear and potion. They've got new items there. Awesome. Buy them. Good to go. However, if they want to buy a bow and arrow, we get a key error because we have no such key at that value. Right? We have no key of that, we have no key that's bow and arrow. So if they have a key error, they say, hey, the shop is not selling a bow and arrow, right? He has nothing for sale by that name. Leave, right? You're causing trouble. You're gone. The end of the function right there. There's a return statement, right? However, if we do have a purchase item, if we found our item at that key, well, now we can sell that thing, right? We say, hey, listen, if you've got enough money to match or exceed that item's value, whatever that item is, whatever its value is, if you have enough money to afford it, then you get it. It gets added to your inventory, right? Also, we remove that gold from your purse of that value. We give you a little statement here saying, you bought such and such thing, right? Cool. Otherwise, we say we can't afford that thing, and then you get booted out. There you go. So now our shop behaves more dynamically. And like many things in programming, at first it seems more complex. It's like it was so much easier to understand when we simply defined with strings what all was in the shop, right? I could just have a big list of, I've got this and this and this and this. They cost this and this and this and this, right? That made more sense right away. It was easier to understand at first glance. However, the reason why objects are so important is that they make things easier to understand in the long term. Once we have, let's say that our game is, 20,000 lines long, and we suddenly want to add a high potion to our game. Well, now, if we're doing things like listing off all of our items manually in each shop, we have to go add that high potion to every single shop's list, which means going and adding in, a new line in the menu, a new if statement, new elif basically to sell you that thing. It becomes a huge pain in the ass. And the important thing about using objects and classes in Python and other languages is it allows you to quickly manufacture things and change things. It makes your code so much more dynamic, right? So, for instance, what we can do now is we can very easily add new items to the game by sort of defining these usable item instantiations, right? These instances, very rapidly. We can manufacture as many spears as we want, as many potions as we want. But before we end the stream here, I'm going to actually talk a little bit about inheritance and how that can make our code even easier. So let's go run the code, make sure it works right now. I believe that it should. I believe that our code now has been totally fixed up to use these new inventory objects, not these strings that just kind of represented loosely the objects themselves, but actual objects that have a name, a gold value, and a function to use them. Right. So make my name John Thomas. Okay. And we're going to, fight at first. We got a Goki, that sucks. Let's use a spear. So we have a spear, a potion, a roll of TP, and a thumb drive. Let's use a spear. Okay, so he taunted me. That's great. Saved me some trouble. Let's attack him. Okay, so he didn't actually hurt me this time. That's great. So I got free 10 gold. Awesome. Let's go shopping. So he has a spear and a potion. As you can see, guys, the menu we're given here is our new menu. It goes through using a for loop right here. Excuse me. Right here. It goes through every item the shopkeeper has and prints off its name and its value. So he has a spear and a potion. It prints off, the spear is 15, potion's 10. I'm carrying 10 gold. What are you buying? Okay, let me try and leave first. Oh, so I got some kind of typo there, huh? Alright, so we got this purchase item. Okay, let's go to the leave. It says here that the purchased item is referenced before its assignment. Oh, I'm sorry, right, oh, it's called Player's Choice now. It's called Player's Choice. I'm sorry, it's called Player's Choice these days. Well, there's your problem. Okay. Let's rerun this code. We had such a good run there, too, against that Goki. Alright, so I'm going to be John Thomas again. I want to go fighting. It's a Goki. Fuck. Let's use a spear. Okay, let's attack him. He attacked me. I can kill him, though. It's fine. Okay, I got 10 gold. Let's go shopping. I want to leave the shop. There you go. So I left the shop. Let's go back to the shop. I want to buy a bow and arrow. Okay, he's not selling that. You leave the store. Okay, that's fine. Let's go back to the shop. I want to buy a spear with my 10 gold. Okay, I can't afford a spear. Okay, that makes sense. It costs 15 gold, right? I'm going to go back to the shop one more time. I want to buy a potion. Okay, so now I bought a potion. Awesome. Let's go fighting then. I want to use an item. So now I have 2 potions. Right? I have this potion and that potion. Cool, I want to use a potion right now. Because I restored some health. I restored 10 health, right? Let's check my items now. Now I'm down to 1 potion. Okay, so that worked pretty well. One of them got consumed. Sick. Okay, so now we can, you know, use the roll of toilet paper. Okay, didn't really do any good there. Let's use the thumb drive. Actually, it doesn't get used up, it's whatever. Let's use 1 more potion, I guess, just to kind of use all of our items. All right. All I have left is the thumb drive. I want to, yeah, use it, I guess. Okay, it doesn't really do anything. So Goki hasn't attacked me yet. I got 30 health. Let's just kill this guy, hopefully. Okay, he's defending. Boy, I'm getting really lucky in this run. He never attacked me once. Nice. I got 10 more gold. I can't really buy a spear with that. Let's actually do 1 more fight here and buy another spear after that, huh? We got a baby Goki. Sick. Let's attack him. Okay, he did a little bit of damage to me. All right, so I got 5 gold. I have 15 gold now. Let's go to the shop. I want to buy a spear. There you go. I got a spear now. Let's fight now. It's a grown Goki. Let's check our items. We have a spear. Let's use it. There you go. I did double damage. Nice. Now let's attack him again. And attack him 1 more time. Awesome. I got 10 more gold. So now we can get gold and we can spend gold. Right? But I want to, before we call it quits here, make our program a little bit simpler by talking about inheritance. So as you can see here, every time we make another spear, we have to define it like this. Usable item spear, 15 item spear. For potions, we say usable item potion, 10 item potion. Now what's crazy about that, if I go down here to our, where we define the player, up here I think, we do the same thing when we create our player. Right here, right? Usable item spear, 15 item spear. What's tough about this is that when we make a new spear, we have to define its name and value and use function manually. And furthermore, it means that although we're doing it manually in a uniform fashion, not every spear is uniform. I could actually very easily make this one worth 13 gold. Right? Even though it has the name spear and it has a value and function, they are not all similar. They're just defined manually each time, right? So we could have 1 spear worth 13, 1 worth 15. And it's kind of a pain. It makes things a little bit less uniform. So instead, why don't we make a class called spear that's always the same, and then instantiate that spear class whenever we want a new spear? Okay, so what does that mean exactly? Well, let's go up here to our usable item class, right? This class, you know, has these same values. Everything is kind of the same. However, why don't we make a class called a spear item? Right? And then we can say here, you know, make a new init for it. And unlike the usable item init, it's going to not need any arguments because all spears are the same. Right? It needs no arguments except for self. I'm going to say here, self.itemName equals spear. Self.goldValue equals 15. Right. Cool. Awesome. Then we're going to say here, you know, that instead of having a self.use function, we're going to actually do it like this. We're going to make a method called def, use item. Gonna take self as the only argument, right? Well, I should probably take game state as well, huh? Let's do the game state as well. And then we're gonna copy paste this code for using the spear. Right here, the item spear. Right, let's go down here and copy paste all this stuff. Okay. I take back what I said about inheritance, guys. We're not gonna worry about that right now. We're gonna talk about making more classes that are more suited to our needs. 1, 2, 3, 4. 1, 2, 3, 4. We're actually adding more indent here. There you go. We're going to talk actually more about inheritance next week, guys, as a way to clean up our code. We're actually running out of time here. We have 10 more minutes left. I don't think I'm going to get too much into inheritance yet. But what we're going to do instead is we're going to talk about inheritance next week on Friday, and then use that to make our code even simpler, even cleaner. Anyway, so what we're doing right now is we have this new spear item class, right? And it comes bundled with this item name of spear, and this gold value of 15. And it has this use item method that takes the game state as an argument. And then it basically does what spear used to do, right? It uses the spear essentially, right? That's cool. Let's go down here and delete this old use item, the old item spear code, because now it's a part of this class, the method of this class, essentially, right? Just to kind of organize our code a little bit, even though it doesn't use self that much, but it really should. Anyway, so we have this new spear item, right? Actually, get rid of this old class here. The old usable item class. We'll talk more later about inheritance and stuff, how to make this a little bit cleaner. Let's do the same thing now for the potion. Right, I'm gonna make a new class here. Class potion item. And we're gonna define it's a init. When we make a new potion item instance, it's gonna give itself an item name of potion. And it's going to have its own value of a 10. It's going to have this method, use item, to take the game state as an argument, and itself, of course, implicitly. We're going to copy paste our old code now for using the potion. Right here. And I think for the sake of simplicity in our code, we're going to get rid of the old roll of TP and the thumb drive, because those have no function at all. They're both basically used as a way to demonstrate ideas earlier on in our series here. We're gonna make our code simpler by getting rid of that stuff. Because really, the only items that did anything have been the potions and the spears, right? Okay. Awesome. Indent it all to kind of line up with our new depth of it being a method here. This line's going kind of long. Let's fix this line using some hanging indents, like so. Okay, so now we have our potions and our spears, and what they are is they are their own classes. Right? We have a spear class, which when you make one, it defines an item name and a gold value, and a use item method, right, to use that spear. We also have this potion item, which has a name, potion, a value of 10, and it has this use item method that uses a potion, basically. Right. So let's go down here and get rid of all of our old item functions, including the roll of TP, the potion, and the thumb drive. Because now we have our spears and our potions as classes instead. Cool beans. So now when we make a new protagonist, we don't need to use these usable items anymore. Right? What we can do instead now is just say here, I want a spear item, and I want a potion item. There you go. Because they don't take any arguments anymore, right? They are themselves just their own classes. We're just making a spear and a potion that way. We're gonna do the same thing now with the a shopkeeper. Right? Go down here. He spawns items as well. These items spawning right here, these usable items. No, let's not do that. Let's just make it into a spear item. Right. And a potion item. There you go. Much simpler. If I can do that in one line now. So we don't need the arguments anymore to define these items, because when you instantiate these classes of spear item and potion item, they actually manually save their own values for their item name and their gold value. Right? That's true of the potion and the spear item. Awesome. And now when you use these items, actually you call them a uniform way. It's no longer an attribute called use function. We're calling a method. Let's go here to our turn item, right? Here we have this item function is the use function. No, let's just call it as a method, right? So we're going to say here, try to get this function and then call it, right? So the item function is going to be this thing called use item, right? That's the function. We can call it with the game state. That works. Okay, so now all of our items have this use item method, correct? Right. So the spear has it, use item, and the potion has it, a use item method. Right. All it does is it uses the item. It takes the game state as an argument. So when we try and go to our turn item here, when we try and use an item on our turn, we go through our inventory and print off the item names of all of our stuff. And then we also get the method app, called item method now. We're going to call that method with the game state. Thank you for the follow, a Cyclone Racer 316. We're just ending our stream here. I would love to stream for another hour and talk about inheritance. That would make our code way easier to understand. But we'll save that for next Friday, guys. We actually have about 10 more minutes left to stream here. All right, so we have these items now that are classes. Let's see if the code works. I think it should, but I changed a lot of stuff. I might have had a typo in there somewhere, huh? Let's make our code into Cyclone Racer. I'll call him Cyclone. And I want to fight, first of all. Now, what items do I have? Okay, so I still have my items, a spear and a potion. Let's use the spear. Okay, that works. Now, do I still have that spear? No, I lost the spear. Good, okay. So let's use the potion now. Get some health. Okay, I'm down to 20 health now. Let's attack this guy. And attack him again and get the kill. So I have 10 gold now. Let's go to the shop. Make sure the shop still works. Okay, it still works. It has a spear and a potion. I want to buy the potion. Okay, so now I have a potion. Awesome. Let's go fighting again. I want to use my potion. Right off the bat. This is a good time to use it because Goki's kind of weak. Baby Goki's kind of weak. Let's attack Baby Goki. Okay. Boy, I did a lot of damage. Oh, I didn't use my potion. Fuck, I'm so stupid. I have to do item first and then potion. No. I wasted a turn there. It's all right. I got 5 gold. That sucks. We're actually probably going to die here. Let's fight one more time. You got another Baby Goki. Let's attack him. Okay, you talk smack. I like that. Oh, got a free kill there. Got 5 gold. Let's go to the shop. Let's buy a potion. Okay, let's go fighting. This is adult Goki. He can kill me in 1 hit now. He has 15 damage. I have 14 health. Use the potion then. Let's go item. Potion. Okay, he defended. He wasted his turn. Wasted his turn again. Wasted his turn again. Let's go. Excellent. Awesome. I got a free kill there. It's free 10 gold. Let's go buy one more potion. I have what? How much health do I have? I have like 24 health, I think, right? Let's actually save our money for a spear. Let's buy a potion. Let's go shop. We're going to buy a potion. There we go. Let's go fighting. Okay, we got a full-grown Goki here. I want to attack him in that case. I'll wait till I fight a baby Goki to use the potions. Oh, I have to use a potion right now or I'm going to die. Let's use a potion then. And then I want to attack him. Damn, almost dead. Okay, I barely survived that. I can buy another potion. Let's go to the shop. I want to buy a potion. Get into a fight. Okay, so he can kill me now. The baby one. He has 5 damage. I have 4 health. Let's use a potion. Okay, let's attack him. Damn. Okay. So I barely killed him. I've got very little health. I have 6 health left, and I have no items. This is probably going to be our last fight. Let's get really lucky. Let's go fight. Okay, he can't kill me in 1 hit. He's a baby Goki. He has 5 damage. I have 6 health. Let's attack him. Oh, he did kill me. He did more damage. I thought he did 7 damage. Fuck. Anyway, so that's kind of a fun game there. We were earning gold and spending gold, and then using the items that we bought, right? It's kind of cool. So let's go review our code and see what all got changed today. Well, what really changed is that we added a shop, right? As of our last stream, when you kill an opponent, you would get gold, which is cool. And then before that, gold was kind of like a score that would add up, and then that kind of be like your final score, how much gold you had, right? But now the gold has a purpose as a currency. It can be used to buy items. And the way we're doing that is by using classes, right? We're actually, whenever we go to the shop here, we manufacture new items, basically, right? We manufacture these item objects from these classes called instantiation. And these objects have attributes, which are data that kind of defines that object's properties. And they also have methods, which are things you can do with those objects. Right? So now, instead of having the player's inventory be filled with strings, which themselves point to functions, we have these objects instead, which can have any number of properties, which makes our possibilities so much larger in our game. Right? The reason why I wanted to use objects today is because now items have a value in gold. Previously, that wouldn't have really been possible to implement with only using strings to refer to items in your inventory. Because like in a real RPG out there, if you ever guys have played Final Fantasy or you've played Dragon Warrior or Fallout or whatever, every item has many properties. It'll have a weight to it in some cases. It'll have like swords have like attack power. Again, they have a gold value. They've got all kinds of, they've got a sprite in some cases. We're using like text here, but they might have a sprite attached to them. Basically, your objects in your world are going to have properties. And it makes so much sense to have those properties be literally attached to the concept of the object itself. I'm sorry, guys. I have a dry throat right now. So, if we've been trying to instead use all of these concepts as loose variables, we could have saved, let's say, a variable to our game state called like spear value, right? We could save a variable to our game state called, potion weight, right? Or shop inventory limit, something like that, right? As we go on adding more and more variables to our game state dictionary, the problem that happens is that it becomes too much of a pain in the ass to manage all of these individual values in this game state dictionary. As we want to add new items, it means adding in all kinds of new values to this dictionary. And then every time you want to maybe add another potion, or add another spear, or add another whatever, it means adding more and more and more and more exponentially. So by breaking your program up into these classes, which have these attributes and methods, the data and the operations attached to that object, and then you can manufacture that object by simply instantiating that class, like right here, you can very quickly multiply the data in your program. You can very quickly add new objects, add new items, add new properties to those items. It's very easy to do as you get better at it. For instance, before we end the stream here, we have another situation that really demands a class. It demands an object, right? It's not really suitable to continue using this game state full of loose variables. And by that, I'm talking about our player character. Let's go look at create new player. Right? Up here, create new protagonist. What we're doing here is we are giving this function the game state, and then this function is adding all these values to the game state, right? The protagonist name value, the protagonist attack power value, the protagonist HP value, whether they're defending or not. All these things are all attributes of the player or protagonist conceptually. Like, in fact, you can even see we've sort of been using like a standard naming protocol, right? Protagonist name, protagonist attack, protagonist HP, protagonist is defending, protagonist inventory, protagonist purse, right? All these names are really making it very clear these are attributes of one thing, right? So why not replace these underscores with periods? Why not have them actually be attributes of the protagonist? Let's go fix that right now before we end our stream, because that's just really demanding to be made into a class. All right, let's go up here to our top of our program. We're going to make a new class called protagonist. Right? And when you initialize it, you give them a name, and that's all that's different, right? You give them a name. So we're going to say here, protagonist name, right? We're going to save that as its name. We're going to say here self.protagonist name is whatever you supplied as an argument, protagonist name. We're going to say here self.attack equals whatever it was. Let's go down there and review it real quick. 6. Right. We're going to say here, if protagonist's name is Chun-Li, then print off, you're the strongest woman in the world. And you get 10 attack power. Otherwise, you get 6. Right, cool. I'm going to go ahead and copy paste the rest of this shit, because I don't want to keep remembering what it is. Let's go down here to create new protagonist, and then grab all this shit. Okay, here you go. Paste it. So now we're going to say here, self dot, I don't know. What am I call this? We'll call it like moniker. You have a moniker. What's up, Nordist Power? Nordist Power. Are you from Northeast Europe? Moniker. Right, you have a moniker. Thank you for the follow, Elisha512. That's kind of a cool name. Okay, so if you're a moniker... Oh, Brazil, huh? Okay, welcome aboard, Brazil. Always pleasure having more Brazilians in the chat. So where does your name come from, Nordist? Nordist Power, huh? I'm pronouncing it wrong. Probably Nordest. If self.moniker is Chun-Li, then print that off. Right. Otherwise, we're going to say here, self.hp is 25. Self.isDefending is false. Self.inventory is a list containing a brand new spear item and a brand new potion item. And then, self.purse is 0. There you go. So now we have this object, right, that has all these attributes to it. Makes sense. So now we can go down here to when we're calling this function originally. We have this function, right, create new protagonist. All it does is change the game state, right? Why don't we instead go down here to the game's main logic? Instead of saying create new protagonist, we're going to say here, game state, we're going to say here, protagonist equals a new protagonist object. And we're going to give it a name of, input, what's your name, son? That's the name you're going to get out of it. Cool. Then we're going to add that protagonist to the game state. We're going to say here, game state, protagonist, is going to reference our protagonist. There you go. Thank you for the follow, a Sticky Wada. It's an interesting handle there, Sticky Wada. Welcome aboard, dude. We're just going to end our stream here in a minute. We're going to actually be playing some Mortal Kombat Armageddon very soon. We're kind of ending our programming stream, but here, guys, every Friday, we do a show called Intro to Python, where I go through and try and talk about basic programming concepts as though we're a total beginner on the other side, right? Because I've never programmed before in your lives. Our next episode is going to be on Friday of next week. It'll be episode 5. We'll be talking about inheritance and using inheritance to make our code much cleaner, much shorter, and much more extendable to make our game much more interesting, right? By episode 5, of course, we're going to be kind of in some advanced concepts. Our episode 1 was really like, what are variables, what are functions, how do programs work, right? But by now, we're actually at the 5th episode of our season. It's going to be a little bit more advanced. I apologize. If you guys want some more beginner-centric type stuff, go to youtube.com/Vencabot archive or search for Vencabot on there. You'll find me on YouTube under that name. You'll find Intro to Python in a playlist, including seasons 1 and 2, where you can go watch from episode 1, where it's kind of like beginner stuff, and we kind of gradually work up to more advanced concepts. But here on the stream live, next week is going to be episode 5, Inheritance, and other more advanced concepts. we're kind of wrapping up here for today. So now we have this protagonist in our game state, right? I'm sorry, I mistyped that like a doofus. There we go. There you go. So, actually, I can just do it like this. Let's actually just copy this code. I'm dumb. There you go. So, now we are adding this protagonist as an object to our game state. Which means that now, instead of referencing game state protagonist HP like this, we're going to reference game state protagonist dot HP. Right? Because the protagonist is now an object. He has attributes, right? And soon he'll have methods as well. Next week. To make things more clear, you know, how the player works, how the protagonist works. In fact, we can actually fix that right now. So we have this HP value, that's fine. That's all well and good. Do battle, go shopping. That's game state, that's fine. Now let's change the way that turn attack and turn item all behave. We're actually going to have these be methods of the protagonist. Right? I don't know. Let's actually not worry about that until next week. It's going to be a little bit involved to change the way things behave with the game state value, right? Basically, it would make sense for things like the spear item and the protagonist to know what their own game state is. From a design standpoint, it makes things a lot easier. But let's not worry about that too much right now. That'll be for next week. Today we kind of introduced some ideas for object-oriented programming, but we're not really exercising those ideas to their fullest potential, right? You guys are kind of watching at home like, well, what was the point of that? Why did we make these objects? What are they for? Have they made our code simpler or more complicated? Well, that's because we didn't really have as much time as I hoped to really exercise these objects. Next week on Friday, we'll be talking about what makes attributes and methods so important, right? Why are they so powerful? How are they going to actually help us in some way? That's going to be a part of adding the game state to these classes as an attribute. Once we have that attribute, we're going to be talking about lots of freedom, lots of flexibility, lots of power to very quickly add new characters, new items, new monsters, new environments, more rapidly than you guys would imagine possible by this point, right? But for now, we're kind of leaving this kind of half finished here with our kind of a whack protagonist class, which is very simply contains some attributes. This might not even work. We should actually make it. We should make it work, right? Let's go make it work. Let's go through and have this use item, right? We're actually going to be calling this use item. It's going to have this player dot inventory. Protagonist dot inventory value. Right. Then we're going to have this protagonist dot attack value here. Right, there we go. Protagonist dot name, or moniker, I should say. How you doing, Akau says? Just in time for some Mortal Kombat, dude. It's gonna be a lot of fun, I think. Okay. Then we have the monster HP. We have the player protagonist, that is. He has an inventory now. Right. That's cool. He has a moniker now. As an attribute. Awesome. Is it Mortal Kombat 10? No. It's Mortal Kombat Armageddon. It's, I think, Mortal Kombat 6? Or 7? Maybe even 8. I don't know. I think it might be 8, to be honest. I think there wasn't a Mortal Kombat after Armageddon until MK9. Okay, so let's see here. So we have this protagonist as a moniker now. That's great. What else we kind of fix here? The player has an inventory attribute now. He's a protagonist, that is. Kind of going through and fixing our old code and making it compatible with our new code. Okay. He has HP now as an attribute, not as a dictionary value. He has a moniker, not a name. Like that. Likewise here, we have to reference his moniker. And he has an HP attribute. Like that. Sweet. He has an inventory attribute now. Awesome. Okay, once again, here we have the moniker now. You got me hooked into VCV, man. It's dope. Yeah, it's a great program. I love it. I'm glad I found it. It's free and it's nice. Nice UI. It's pretty stable. Not that buggy, all things considered. Okay, here we have the protagonist moniker. Okay. Actually, what I'm going to do is I'm going to actually do edit, replace. I'm going to replace game state, protagonist name with game state protagonist dot moniker. Okay. Let's find. We're going to replace. Find. Replace and find. Okay. Replace. Yeah. There you go. Okay. Keep it growing. Keep it growing. Okay. Good. Replace all this stuff with our new code. Awesome. There you go. Now we're going to replace protagonist HP with protagonist.hp. Okay. Find. Replace and find. Replace and find. There we go. Nice. Awesome. Fabulous. Okay. Do the same thing with the protagonist attack. Right. It's going to be protagonist.attack now. Find. All this stuff here. Do some damage. Do the same thing with player inventory. Change that to protagonist.inventory. Find. There we go. Okay. Awesome. Now we can replace player is defending with protagonist.isDefending. Okay. Awesome. I think that's everything, right? That's all the player stuff. Let's go double check. He has a moniker, he has attack, HP, is defending, inventory. Oh, he has a purse too. Let's replace that real quick. Replace, I'm going to replace game state protagonist purse with protagonist.purse. Make our code more object-oriented. There you go. Akawas says, CPU hungry. Yeah, it's very, very intensive for sure. Yo, lurk mode is moo. Let's go. Go lurk mode. Glad you're here, Cow says, in any case. Almost time for Minecraft later tonight. We're going to be playing some MK Armageddon and then some Minecraft. All right, I think this code should work. Let's go and patrol for long lines now that we've changed all of our stuff. Are any lines super duper long? Yeah, this one's a little bit longer than it could be. There you go. Suppose there's a really long line. Can I actually scroll this way? And let's see here what we got. Any lines too long now? I think we are pretty much good to go. Here's one's kind of long. Okay, there we go. What else we got? This one might be a little bit too long, huh? No, I guess not. Okay, that's fine. All right, there we go. And so now our code is more object-oriented. Of course, I mentioned earlier that it's not really as dynamic as I would like because we kind of ran out of time today. So we kind of got our shift over to object-oriented code kind of halfway done. Right? It's still kind of ugly. It doesn't really work. It's not really making our program any cleaner by having these objects here. In fact, it might be making it a little bit messier. But you guys are going to see next week why we're using objects and really what their benefit is. Right? Why we're actually going to be taking advantage of this power we're having, that we're kind of adding to our toolbox. Right? You're guys going to see next week when we start adding in more monsters, more types of items, more environments, more options between fights, like to explore dungeons and find treasure. And you're going to be like, how are we making so much progress so fast? Well, because we have these objects, right? They can make things like adding new characters and new items very, very easy. But guys, as usual, if you guys enjoy hanging out, want to keep the channel online, check out my Patreon page at patreon.com/Vencabot. Even $1 is a huge help. Helps me buy gas and groceries and that kind of thing. Go to Third Strike events and kind of entertain you guys. Also, you know, if you're like me, you're totally broke, you want to help out, you can't really afford it. I totally understand that. I know that helping a streamer out financially is not the top of most people's budget lists. You know, help for free. Get in the chat, come say hi, follow on Twitch, tell your friends we're here, spread the word, save clips. Check me out on YouTube at youtube.com/Vencabot archive, or just go on there and search for Vencabot. You'll find me that way too. We've got an entire playlist of Intro to Python, including Season 1 in its entirety. That's a Pokemon example. On day 1 of that season, it was like, what is a variable? What is a function? What is a program, right? How do programs work? And then by day 6, we had a fully working version of a Pokemon battle where you could define your own Pokemon, define your own skills, and have really cool fights. It's kind of cool. And then we also have half of Season 2 on there right now, which is like a Zork sort of adventure game, kind of like a puzzle game. Those are kind of fun. And then very shortly, we're going to have this season on there, you know, up to its first half, which is kind of like a JRPG, kind of like a Dragon Warrior kind of thing, basically. One-on-one monster battles. It's kind of cool. Also, we've got lots of gameplay, long plays, fighting games, all organized by Game and Plays. We have more than 1,100 videos. If you're a Patreon subscriber, you have access to even more videos, including this season, Intro to Python, is on Patreon right now, because it's kind of new still. But I'm going to go a very short break, come right back with some Mortal Kombat Armageddon. I will see you guys very shortly. Thank you for the follows, guys. One more time. We are a variety stream. Don't get discouraged if you see me playing some Street Fighter 3 Third Strike, or some Smash Brothers, or some Minecraft later tonight.
Wait, what? How'd he get back?
We program here every Friday from around 6:30ish to around 9:30ish Eastern time. Right now it is 9:22 Eastern time. We do programming here again every Friday at the start of our stream at around 6 in the evening Eastern. That's GMT -5. You know, on Mondays, Wednesdays, and Thursdays around the same time, we do a game design. We're talking about making our own game on a larger scale. That's not really like Intro to Python. It's more like some advanced concepts, talking about game design in particular. But again, on Fridays, it's kind of like a special show here where we kind of teach Python to beginners. Then we also do, again, lots of gameplay here. Lots of Minecraft and Smash Bros. And Third Strike and other games. So if you guys see me playing some games, don't get upset. It will be more programming every Friday. Come back next Friday for more Python action.
Yo, Mr. Dark
Minecraft, Steve. Got a cow says mooing at Zanzu. Who wouldn't? Who wouldn't moo at Zanzu given the chance? Let me upload our new code. I didn't even test to see if it worked. Let's test to see if it works real quick. If you want to see some COD, go follow Mexican's channel. That man's got COD. It's just for fun. Haven't you seen me? Okay, so everything's still working. TSM Bootcamp 5. Bootcamp Flick 5 months. You're trying to have a good time, dude. Yeah, have a good time learning Third Strike. Everybody's welcome here. Okay. Kill blood section seems alright though. Good, good. I have no problem. Happy to hear that, Zanzu. Hopefully, at least having some noise in the background is somewhat comforting. I know that you're not exactly super into Python.
Jab, machine gun blow.
But you know, sometimes having a voice in the background can make things a little bit nicer.
He doesn't even know what the buttons do. Say that a random uppercut. Full screen, 8th uppercut. Got the rage quit.